Yeah, streaming is.
Click on Alt Tab and go to YouTube. YouTube suggested me live streaming over here. It will play over here. That's all for moment, sir.
Yeah, yeah.
So unmute yourself and you can start from the first slide.
Sorry.
Unmute yourself, unmute over here, and you can start from the first slide, I think.
Okay, 1 second. Let me put
Just hold up, let me just check out the link and all. I'll just talk to. So you can close the end test.
Yep.
Disconnecting the call, sir.
Yep.
can start from the first slide.
Sorry?
Unmute yourself, unmute over here, and you can start from the first slide, I think.
Okay, 1 second. Let me put the
Just hold up, let me just check out the link and all. I'll just talk to host. And you can close the end test.
Yep.
Greetings, warm welcome everyone to the second session. That's a continuation lecture on the percentages too. I hope my voice is clearly reaching out to you. So I'll continue with where we stopped on the first lecture on percentages. So in the first if you have not watched the first lecture on percentages, I suggest you take a look at that particular video, which is in our YouTube channel. So once you take a look through that, I suggest that you can continue, you can come back to the percentages too. That would be a better sequence to do it. So here we go. I'm continuing with the second lecture. I'm continuing the second lecture on the percentages. So if my voice is not reaching clearly out to you, you can use the Telegram and you can let us know that if there is a missing clarity, so that I can adjust the settings at my end if there is any. So here we go. Let me start with the recap of what we did there, what we did in the previous lecture. So there we spoke about the fraction percentage equivalence. In fact, I gave you sufficient homework as well. I presume that most of you have gone through that homework and you are here today. Fraction percentage equivalent was one of them, one of the homeworks that I suggested. I suggested you to do the tables till 20, and then I asked you to run through the percentage equivalent of fractions from 1 by 2, which is 50%, 1 by 3, 33.33%, and so on, so forth, up to 1 by 25, which is 4%. I presume most of you have gone through that. And then we also talked about not only the fraction percentage equivalent, but we also spoke about multipliers, all right, from percentages to fractions to multipliers, and the reverse order as well, right? Now that's another skill that we learned in the previous lecture. I presume that most of you remember all right, what we learned in that particular lecture. Otherwise, you might have to go back and learn that, and then take up this particular lecture, because I'll be discussing today the applications and few more concepts which one should know in this percentage lecture, which would be useful as we go along most of other topics of the aptitude, most other topics of aptitude. So here we go. Let us start with a quick recap on fractions, a small drill. Let's start with a small drill on what we learned in the previous lecture. We talked about, say, 5 by 11. So I'm just talking you can read out your answers to yourself. For example, the first number, which is 5 by 11, first number which is 5 by 11, you may say that okay, that is nothing but 45.45%, because I asked you to remember those numbers most directly there, right? 3 by 8. All right, now so here we go, 3 by 8, 37.5%, 7 by 9, all right, which is nothing but 77.77%, 13 by 20, which is 65%, and so on. I'm sure, all right, now you are as much comfortable as I am on the other side, all right, with your homeworks. I'm sure that okay, you guys are pretty comfortable on the other side as well. I'm hoping that, right? Yeah, 17 by 25, all right, which is 68%. See, what is coming onto your mind? You might not have done 17 by 65, but all right, what comes to your mind is, hey, you know what is 1 by 25, right? 1 by 25 is 4%. Therefore 17 into 4, all right, which is nothing but 68, all right, that's what you would be doing. Yes, 6 by 7, all right, which is nothing but 85.7%, roughly around that. 7 by 8, you know that, okay, 7 by 8, which is 87.5%. I'm sure I'm just giving you these drills so that we kind of feel comfortable about it, or that we are feeling comfortable about it. That's the whole idea about this. 11 by 12, which is nothing but 91.66%. All right, 91.66%, and so on, right? Now, and so on, or you can do all other fractions as well. I think, all right, you can do it. All right, you can do the other numbers. This is a quick refresher for you, stating that, okay, this is something that we learned in the previous lecture. And I also told you that, okay, you have to go back home and you should have done this by now. So let me continue. And in addition to this, what is the other thing that we did out there? All right, the other thing that we did is, I told you that, okay, if there is a if there is a fraction, if there is an increase, all right, now if there is an increase of say 40%, if I want to increase a number by 40%, right, there is a number n, if I want to increase it by 40%, we spoke about the multiplier in that particular class. We said that 40% technically is nothing but 2 divided by 5 with a plus sign. I told you retain the denominator as it is. When you want to write a multiplier, add 5 plus 2, which becomes 7 by 5, which means if there was a number, I wanted you to increase it by 40%, you say that your resultant number is 7 by 5 times of n. All right, this is another thing that we kind of learned there. Hey, what if there is a number? All right, there is a number, I want to reduce, I want to reduce it by 28.57%. I decided to reduce by this percentage. Therefore, what is the number I should be writing? First, you write the fraction for this. 28.57 is nothing but 2 by 7, or you would write it as 2 by 7. I said that I reduce it by this percentage. Therefore, you write the multiplier for this, retain this 7 as it is. 7 minus 2, which would become 5. So therefore, you would say that, hey, my resultant number is going to be 5 by 7 times of whatever that particular number was, right? Yeah, these are a couple of things that we kind of learned in that particular previous lecture. Let's capitalize and let's continue built on this. Maybe already now another drill on a little bit of calculation before we move further. There's another drill. Let's take another drill on this. So you said that, okay, find 36.66%. Sometimes what happens is you come across these numbers. You may find very hard in your mind that, hey, I never came across a number which is 36.66%. All right, now because you would have learned all this chart, whatever I advocated to you. But despite that, you might not have come across this particular number which is 36.66%. Fair enough. What you do is you break and work with them at times. You kind of break them. So how do you break it? 36.66% is nothing but 30%. Well, that's which is nothing but 30%. All right, which is 30%, and 30% plus 6.66%. You can break it in your mind, which means 30% of 90 and 6.66% of the 90. Hey, what do you mean? 30% of the 90 is nothing but, always percentages for us are nothing but fractions, right? 3 by 10 times of what? All at 30%. 30% is what? 3 by 10. 3 by 10 of what? This number, which is 90. Okay, plus. Hey, what is 6.66%? 6.66 is nothing but 5. 6.66 is nothing but 1 by 15. Well, that's a fraction equivalent of that percentage, which you would know. All right, 1 by 15 times of 90. So therefore, what do? You break it. All right, if you come across a number, all right, you come across some new percentage number, all right, which is not, all right, which has been not learned through those particular charts, all you do is you break them, conveniently break them, break and work it out. All right, 3 by 10, 10 times of 90, pretty simple, 27, right? 1 by 15 times of 90, all right, which is nothing but 6. All right, therefore you would say that your end result is nothing but 33. All right, that's how you go about that. Take a look at the second one. Find 72.5% of 160. Multiple ways to do with this. You may say that, hey, all right, now 60 plus 60%, I can do this as 60% plus 12.5%. That is one way of writing this. Hey, some of you may also be wondering that, hey, no, I will do this as 75% minus 2.5%. That's okay. All I'm trying to say is when you come across a number which is not, all right, now which you have not learned, learn to break them. Be it a addition of two numbers, two percentage numbers, or a subtraction of two percentage numbers, does not matter which way you break it. Break it conveniently so that you can do the calculation faster and effectively, right? Yeah. So 60% of this, we all know that 60% is nothing but 3/5. 3/5 of what? 160. What is 12.5, which is nothing but 1/8. 1/8 of what? Which is 160. 1/8 of 160. Right? Yeah. So that's how you'll be doing it. So calculations from here are pretty simple. All right, we worked out the numbers in such a way that the calculations come out to be, all right, calculations come out to be pretty obvious here. Right? Yeah. So my point here is what? All right, when you see this number 72.5, the teaching point here is, okay, break it conveniently if that number is not known to you. Okay, third skill, let us learn the third. So let's take a third example out here. Approximate value of this. So now let's say that, okay, he's saying that something plus something. Tell me what is the value of this. Guys, percentage is a symbol. As I told you, the percentage is just nothing but a symbol. Now look, what is given to me? 30% of 66.67%. What is given to me is, already if I were to write it, 30 by 100 into 66.67. Yeah, I can shift this, man. I can shift this. What do you mean? 30 into this is nothing but 66.67 by 100. Yeah, what did I do? Can I shift the 100 like that? Why not? It is the same value. I shifted under this. I took from this 30, I brought it under this. Now this is pretty convenient factor. This is nothing but 66%, which means you can write it as 30 into 66.67%. That's what you are trying to say. 66.67 by 100 is nothing but 66.67 percentage. That's what you write. What is 66.67 percentage? Which is nothing but 2/3. A 2/3 of what? 30. Okay, what is the teaching point here? A percent of B is also nothing but, let B percent of A. Let A percent of B is nothing but B percent of A. That is, we can shift this percentage symbol conveniently. We can shift this percentage symbol conveniently. Look at this. Let 30% of 66.67 looks valid, looks shabby. Let this look shabby. Rather, let now you just put that percentage sign on the other side. Let me redo this. Let me redo this. What I meant, we can shift the percentage sign. Therefore, first thing, I interpret in my mind this particular problem as 30 of 66.67%. I will interpret it like this in my mind. Alright, this is how I'm going to interpret this. Now it becomes easier question. Therefore, it becomes 30 into 2 by 3. Alright, calculations are pretty simple from here. Alright, which is nothing but 20. Alright, that you write it as 20. Very same thing can be done on the other side as well. You can do the other side as well. Pretty similar action. 16% of 375. Fair enough. You can do this directly. That is one way. Alright, that is also one way. So you know that what is 16%. You recall one of the factors of that, 4%. 4% is 1 divided by 25. Therefore, what is 16%? 16% is nothing but 16% is nothing but 4 divided by 25. You would say that that is 4 divided by 25. That's one way of dealing with this. 16% you write it as 4 divided by 25 times of 375. That is one way of dealing with this. Now look at the other side of it. Other side of it. Alright, I asked you to learn numbers so that some recognition. You can also write this as a, can I shift the percentage onto this particular side? Because when I look at 37.5, this reminds me about 37.5. 375 reminds me about this. Fair enough, absolutely fine. So therefore you can also treat the second part, or second part of the issue as 16 of 375%. Already you can also treat it like this. Alright, you can also treat it like this. Fair enough. Okay, what is 37.5% here? What is 37.5%? 37.5% is nothing but 3 divided by 8. Hey, therefore, what is 375%? 375% is 30 by 8. Alright, this decimal place is shifted on the other side. Alright, out of this 37.5, which means what did you do? You multiplied by 10. Then multiply the other side also by 10. Therefore, it looks like 30 by 8 now. So you can also write this as 16 into 30 by 8. 16 into 30 by 8, which would technically become 60. So therefore, that's another way. Another rule is what? Hey, you need to understand that from calculation perspective, be flexible. Be flexible from calculation perspective, right? Yeah. So here we go. Maybe I'll let a little bit of warm up on the calculations. The idea of the class was not this. The idea is, okay, making you warm up, because you might wonder that, hey, despite knowing so many values by now, I'm still already stuck with some of the numbers. Don't bother. All right, now, so there is a way to unleash them. You just break them. Learn to break them. Wherever convenient, break it if the number is not known to you. Second thing, from the calculation perspective, remember that A percent of B is nothing but B percent of A. Be flexible to change the percentage symbol, because after all, it is a math. It's a by 100. Now where you put that 100, it really doesn't matter, right? Yeah. So therefore, all right, now this being flexible with respect to percentage symbol, that's point number 1. Breaking is point number 2. Let's go on. Let's look at some of the applications of the multipliers, etc., that we learned from the previous lecture. All right, let's try and understand from the previous lecture. So let's take one of the examples out here. So I can use multiplier already in many terms. So let's take a look at this. The population of a small town is 30,000 in the year 2017. It increases by 6.66% in 2018. Also, it reduces by 25% in 2019. So it's in succession. All right, now, so population increasing and decreasing is not on the base of 2017, right? It is not on the base of 2017, right? It is not on the base of this. So what happened? 2017 to 2018. All right, now the 2017 becomes the base. When I'm looking at what is the figure for 2018, the 2017 is the base. But when I'm looking for the decrease for 2019, it is not on the base which is 2017. Instead, it is on the base of 2018. All right, in succession. That is what you mean by in succession, right? That is what we mean by successive percentage increase or decrease, successive percentage change. All right, that's a concept that we call. Find the population of this town in the year 2019. Look, we already learned about the multipliers. Take a look at that. Increase, all right, increased by 2016, 6.66%. From 2017 to 2018, there is an increase of 6.66%. Okay, all right, let's keep that 6.66%. There is an increase of this. All right, whatever be the population in 2017, we'll come to that number. Number is given there, right? Number is given to us. We'll come back to that particular number in a while. Second part, from 2018 to 2019. From 2018 to 2019, the increase, decrease, there is a decrease of 25%. Now listen to me, guys. All right, now listen to me. So firstly, let us understand that what is 6.66%. 6.66% is plus 1 by 50. All right, that's a one. So therefore, what is the multiplier? Increase and decrease is a function of a multiplier. It is not a function of a fraction alone. We already learned in the previous lecture, all right, that it's not a function of, all right, only the percentage fraction, percentage to fraction alone. It's a function of multiplier. How do I write the multiplier? Therefore, you retain the denominator as it is. You add 15 plus 1. It will become 16. Okay, what was the figure in 2017? The figure in 2017 is 30,000. So what is that we are trying to say? 30,000 got increased by this much. Now this is the number for 2018. If you say that, hey, what is the figure for 2018? This calculation that we have done for now is the figure for 2018. But the author said that, hey, I am not interested in 2018. I am also interested in what happens in 2020, 2019. Right? Yeah, therefore we are going to 2019. 2019, there is a decrease of 25%. Some population control has happened. There seems to be a decrease here. Decrease of 25%. How do I write a fraction? Decrease of 25% is 1 by 4. All right, that's how you write a fraction. Yeah, how do you write a multiplier for this? Multiplier for this is 4 as it is and then 4 minus 1. Therefore, you would say that, okay, this is going to be 3 by 4 times. Is this the final answer? Yes, that's a final answer. What did we learn? In the last class, we learned how about the multiplier. What we are now doing is we are using multiplier in succession. That is more than once. Can I use multiplier more than once? Yes. All right, we are using it in succession, one after the other. Hey, can there be only 2 multipliers? No, it can be as many multipliers as possible. I hope all right, now all of you got this. Okay, if I wanted the population in 2018, I could have stopped at this particular bracket. I could have as well stopped at this. Okay, since I wanted still 2019, this was the figure for 2018. I said that, hey, this has to again further decrease. All right, it has to decrease by 3/4 of the number, all right, which leads me to 2019 figures. Now, this is the calculation which is kind of required out here. All right, this is the final calculation that is required, all right, which can be simplified, all right, which can be simplified from here. Right, 15, 2000 times, 15, 2000 times, then 4, 50 times. All right, 450 times, right? Therefore, you would say that 48 into 50, all right, 48 into 50, all right, which is nothing but 24,000. All right, 24,000, right? Now, so therefore, your result looks like, okay, it has now become 24,000 after some population control. They started off with 30,000. They started off with 30,000. When they came to 2019, their population is now 2,400. Okay, what is that we are learning here? We learned about multiplier, but I can use the multiplier in succession. Right, we'll see some more example. You become more comfortable, all right, with the first example. It kind of sounds familiar, all right. Now, so you're kind of like, so black is becoming gray. Right now, sometimes when you don't know the concept, we call it as a concept of black. You're in black. Right now, black, the idea of the session is what? To make it white. So how does it happen? Through gray. Through gray. Probably after one example, it looks like little gray area. Fine. Okay, kind of understood. There are 2 multipliers. Some of you might have completely understood. At times it looks like gray. Don't bother. All right, we'll do a couple more examples. You'll start feeling comfortable about it. All right, let's take a look at this question. Let's take a look at this question. The present salary per day of a worker is 264. That's a present salary. It has increased by 10% and 20% successively in the last 2 years. What was his salary per day before 2 years? Right, so what is happening here? All right, now, so whatever was that, all right, there was a all right, present. This is a present. All right, we are into the present. Okay, we are here at the present. So there was a past. There was a past initial, let me call it as the initial salary. Initial salary changed once by 10%. Initial salary changed once by 10%. Okay, it has become some number in between. Then what happened? All right, now say let's put it like this. There was a year one, the person started in the year one. First is changed by 10%. Okay, now that's a year two. Now whatever the earning that he was getting, now it has changed by 20%. It increased. All right, yeah, salary went on to increase. Good performance, right? So this 20%. Therefore now we are in the year three. What did author say? He is giving me this number. He's saying that, look man, the number here is 264. What is he questioning? He is questioning that what is the number here. What is the number here? So how do I reach it? Via multiplier. All right, via multiplier, just like the way we did in the previous question. So but then we don't know this particular value. Let me call it as x. All right, there would be a value called as x out here. So let's try this. All right, let's try this. Let's do it once again in the similar fashion. Let's try it in the similar fashion. So what is this? So you are saying that 10% fraction 1 by 10, all right, plus 1 by 5, that is 20%. Fraction equivalent, percentage fraction equivalence. Then multiplier. What is the multiplier associated with this? Multiplier associated is 11 divided by 10. All right, denominator as it is, add these two numbers. Denominator as it is, add these two numbers. Therefore you are saying that 6 by 5. Succession, one after the other. Succession, you are doing it in succession, one after the other. Hey, what was the initial value? This x as it is. That's what I want to find out. This is x. Hey, what is the final value? Equal to what? This particular number, which is 264. All right, that is the structure. All right, that's what the author is trying to tell us. Fine. So let's simplify this. Therefore let's simplify this, right? So 11 2 times 22 and 11 4 times 44, then 6 4 times. Therefore take the other numbers. Therefore x is nothing but, take this, all it 4, or it shift this 5 and also this particular 10 onto the other side. Therefore 4 into 5 into 10, all it, which is nothing but 200. All it, the person's daily wages were 200. From 200 he went on to reach 264. He started off with 200. He got two increments. One increment is 10%, the other increment is 20%. Therefore this person is now earning 264. I guess now you are getting a little more comfortable, right? Yeah, with the second example you must be getting a little more comfortable. So if you are comfortable, let me twist it now. Let me twist this particular question. All right, let me twist this. Right, you might have felt comfortable by the time you did the second question. Let me twist it a little bit. Let's see all it knows. So how do we work on this? So read this question carefully. Read this question carefully, slowly and carefully. From the salary of an officer, 10% is deducted as house rent. He spends 15% of the remaining salary on his clothing. 10% of the balance is again nothing but the remaining money, all right, on recreation, entertainment. After all these expenses, he is left with rupees 2,754. Find his salary. Now look at this. What is finally what author is talking about? Focus on what is being said. Finally he's left with, all right, finally he's been left with, all right. The question is what is left with. Therefore focus on what author is interested in rather than being focused on what we are interested in, what we are good at solving. We also understand about what author is interested in. He is left with this. All right, author, he's saying that he's left with this particular figure, which means, all right, now we are talking about the saving. All right, we are talking about the saving. Therefore why don't we focus on saving from the beginning? All right, why don't we focus on the saving from the beginning? All right, let's understand this. What do you mean by from the beginning? Let's understand. Let's go here. First fragment, salary. Okay, this person gets s as the salary, let's say, or x. Let's say that the person's salary is x. All right, he starts with salary x first. All right, now first cutting. What is the first cutting? 10% is deducted. All right, minus 10, deduction. I will come to the saving later. 10% is deducted, right? Okay, let me write the percentage only. 10% got deducted. All right, 10% got deducted. Now whatever was the figure, all right, there will be another figure called x1. All right, it would have become some figure called x1 after the deduction, all right, which I am not interested. Further, all what happened, whatever is left, he's saying that 15% of the remaining, all right, salary is on clothing. Okay, there is a deduction from there. It's getting decreased by 15%. It will become some figure called x2. Then what's happening? He's spending 10% of the balance amount on recreation. Fine, again he's spending 10% of this money on recreation. Now he's saying this, at this point in time, I don't have to necessarily write this x3. Fine, the value is given 2,754. All right, this is what is left. See, earlier we did some positives and negatives. Now this is completely balancing here. Okay, so balance, which means the subtraction. So x times of, calculation perspective, x times of 10%. Let me write the multiplier directly, friends, because the idea is what? Idea is like, so you start with a percentage to the fraction to the multiplier, but at some stage you got to learn to do it directly. All right, you got to learn to do it directly. All right, yeah, if I write the fraction, it looks like this, minus 1 by 10. I write the multiplier, it looks like 9 by 10. All right, for your reference, I'm writing the fraction on the top. Hey, if I write the fraction, it looks like 3 by 20. It looks like, all right, no, it looks like 3 by 20. All right, why? Because 5% is nothing, 5% is nothing but 1 by 20. So therefore, you will say that 15% is nothing but 3 by 20. So minus sign. So how do you write the multiplier for this? Multiplier for this is what? 20 as it is. 20 minus 3, therefore 17. 17 by 20. Good. 10%, what is the fraction? 1 by 10. Multiplier minus 10 as it is, therefore 9 divided by 10. Hey, what is this particular value has become? 2754. We need to simplify this particular value, right? We need to simplify this particular value. Let's see this. Let's simplify this, right? Yeah, 2 3 times 2 3, all right, 9 3 times 9 3 times 9 3 times 0, then 9 8 times, sorry, 9 6 times. Let 9 6 times, 1 9 is gone. Let me cancel with this 9. Let me cancel with this, then 9 3 times, all right, 27. Then 9 4 times, which is 36. All right, 9 4 times, which is 36. All right, then 17. All right, 17 2 times. 17 2 times. Technically, what is that you are trying to say? X 1 by 10 is left because 9 is gone, right? Then you have 1 by 20, all right, because the other 17 is gone, and then you have 1 by 10. All right, 1 by 10, which is equal to 2. All right, that is the figure that you have. Therefore, x is equal to 4 followed by 3 zeros, which means it has become, its salary was 4,000. So you are saying that, okay, he started off with a salary of 4,000 rupees. He started off with 4,000 rupees. From 4,000, after his expenses, he is now left with 2,754 rupees. Pretty simple one. What did we do? We just understood that, okay, there is a deduction which is happening at every stage. All right, there is a deduction expenses, all right, expenditure. There's a deduction which is happening in succession. Because it's happening in succession, you went on to write their multipliers. Okay, now this is called as successive percentage increase or decrease. One multiplier is used for each percentage change. Percentage change means already either it can be a percentage increase or it can be a decrease. Percentage increase or it can be a percentage decrease. Each multiplier used for one change. Hey, what if there are too many changes, like in this particular example? Well, there is first change here. Or if there is a first change, there is a second change, and there is a third change. If there are too many changes, then those many multipliers has to be used. That is all the concept that we were talking about, right? Yeah. Now these are some of the applications that we already, now that we learned from the previous lecture. Whatever we learned from the previous lecture, the multiplier drill that we have done. Alright, if I put words to that particular concept, now already if I put the words, these are some of the examples that we have dealt with. Alright, examples look something like this. All right, the examples might look something like this. All right, let's look at another concept. All right, let's bring in this. The multiplier is done. All right, I can still use the multiplier. I will just give you another fresh concept as we go along here. So let's try and take a look at this. There are multiple ways to deal with this. Let's take a look. Because we know multiplier now, let's deal with the multiplier for now. Let's deal with the multiplier. Listen to me carefully, friends. The price of a car increases by 30% while its sales come down but by 20%. All right, what is the percentage change in the total revenue? Now look at this. What is revenue? Revenue is a function of, all right, revenue is a function of price. Price is the value of one piece. That is what we call it as a price. And it's also nothing but, while it's sales is nothing but the quantity. Price, and there is a quantity. How many pieces that you have sold? How many pieces of car that you have sold, right? Price and quantity. Therefore, we know that price into quantity is nothing but the sales revenue. All right, the price at which you sold each car and how many cars you sold, that gives me the revenue, that gives me the complete revenue out here. So how do I do that? All right, now look at the change in the price. Again, the multiplier, I can use the multiplier concept out here. You can say that price was one full price, quantity was one full quantity, revenue was one full revenue. I'm not saying that there was one piece, one full quantity. You may say that a lot of 100, all right, 100 cars put together is one quantity for me. Does not matter. Put it like that. All right, say that initially it is something like this. So therefore, when you are saying that the car price increases, already increases by 30%, what is happening? The price, on the price side, there is an increase of 30% multiplied by, all right, now the sales are down because the car price went up, the sales went down. Sales are down by what? 20%. Sales are down by what? 20%. I am saying that, hey, therefore, what is the change in the revenue, man, here? How much percentage this will change? All right, of course, this has to change by some X percent, let's say. This has to change by this X percent. Therefore, I'm interested in the value of this particular figure called X. I'm interested in that particular value. Let's say, how do I write 30%? Again, multiplier, write multiplier, friends. Directly write the multiplier for this. Okay, let me write the fraction one more step. I don't mind writing once more for you. 3 by 10. That's a fraction. Multiplier 13 by 10. Multiplier 13 by 10. Fair enough. Take the next one here. 20% decrease minus 1 by 5. minus 1 by 5, write the multiplier, which becomes 4 by 5. This is the revenue figures that you are talking about. These are the revenue figures. Hey, what is this revenue figure? All right, you'll say that, all right, now this is 68 divided by 50. Okay, I told you from the revenue. Right? This is the multiplier. This is the multiplier for revenue. How did I do? I just multiplied them. I got the multiplier for revenue. Product of this is nothing but the R, because R was the unknown here. So you multiplied them, you got 68 by 50. Now look at it. Whenever you had this, I told you how to get the fraction. If you know the multiplier, how to get the fraction, I told you retain this 50 as it is. Ask a question, is this more or less than 50? How much more than 50? 18 more than 50. Alright, you would say that, hey, this figure is 18 more than 50. That is what you are going to say, 18 more than 50. You are saying that it is 18 more than 50. Sorry, 52. My mistake. Okay, so therefore you are saying that the figure is 2 more than 50. You are saying that the figure is 2 more than 50, but I want a percentage. Percentage means what? Altered how out of how much here? Out of 100 how much? All right, now you are saying that the figure is 2 more than 50. Out of 100 how much? Right, out of 100 how much? Out of 100 it is 4%. Or you can simplify it from here also, as I told you in the last class. This is nothing but 1 by 25. You are saying that the fraction is 1 by 25. I directly know the number. What do you mean by 1 by 25? 4%. Well, no, I didn't recognize the number. Then multiply by 100. I taught you in the last class. Well, whenever you have a fraction, how do you convert it to a percentage? You multiply it by 100. Well, therefore you multiply it by 100, you get the 4% figure there. Right? That is the way that you can kind of carry it on. Okay, I hope all of you made some sense out of this. You made some sense out of this. Okay, let me do one more. All right, if you have not caught up this particular point clearly, let me try one more for you. Let me try one more. Just like as I said in the beginning, right? Now, so black to gray to white. Right, now that's a sequence. So therefore you look at one question and you don't panic. All right, I didn't understand suddenly. Don't panic about it. Allow yourself some time. Don't be harsh at yourself. At times, like, no, we demand too much out of ourselves. Right, we spend less time and we think that, okay, I need to get this immediately. Hang on, allow some time to yourself. All right, now it is education is not a revolution, it is an evolution. Right, mind evolves. If I never said that the mind revolves. All right, now so it's not revolves or revolution. It is about evolution. Allow some time. All right, you will understand it. Let me take one more example. All right, let me take one more example. All right, probably, all right, with this you try and connect much better. Try and connect much better. Let's take a look at this. What is happening? The number of seats in the cinema hall increased by 25%. Assume that the cinema hall runs houseful all the time, houseful. All right, that's the whole idea of this question, right? Yeah, so the number of seats in the cinema hall increased by 25%. They increased the seating capacity. All right, today because of COVID we are decreasing the seating capacity, saying that maintain some distance. Assume this was a different situation. All right, they're increasing the seating capacity, or put some additional chairs out here. Right, 25%. Price per ticket is decreased by 10%. All right, therefore the price also they reduce. Price per ticket has come down. All right, because they want to increase the volume, and because there is a discomfort, because already you are putting extra seats, probably there is a discomfort, therefore you are giving some reduction. They decrease, the price is decreasing by 10%. What will be the effect on overall sales figures? All right, now which means the revenues, what happened? Did finally the revenues increase, or did it finally decrease? So now look at that. It's again in the form of A into B. All right, whenever it's a product, hey, it need not be A into B, it can be A into B into C also. All right, you can say that, hey, can I say that, okay, what if it is A into B into C is equal to D? All of that is fine, guys. All that is fine. I'm just saying that, how do I use multiplier in tandem? All right, in succession. Basically, how do I use it in succession? Because in the last class we learned how to take it one at a time. Now we are saying that, hey, can I use more than one? Of course, yes. We have already seen, all right, more than two also can be used, right? So that's the whole idea here. Fine, let's take a look. So what is happening here? All right, now one, the capacity, all right, number of seats into price per seat. All right, that's the number of seats. Already S is number of seats into price per seat. All right, now what is each seat that is got? Price per seat is nothing but the revenue. All right, that becomes the sales revenue there. All right, yeah. So let's take a look at this. What has happened to the seats? Seats increased by 25%. The seats increased by 25%. Hey, what about the pricing? Pricing, all right, now so you reduced the price per seat by 10%. Hey, therefore what is the change in the revenue? Fine, as you said in the beginning, hey, it was one full seat, one full seating capacity, one full price per ticket, therefore one full revenue, something like that. You don't have to write it. That's just in your mind. That's in the backdrop of your mind. What matters to you is, all right, now so what is that? All right, what is the seat? What is the increase in seats? Write the fraction here, guys. Therefore simply write the fraction. All right, fraction here is nothing but 1 by 4. Therefore what is the multiplier? 5 by 4. All right, multiplier, you guys will be all right now very comfortable by now, right? You must be very comfortable. Okay, 10% is what? 1 by 10. Hey, therefore what is the multiplier? 9 by 10. Therefore, what is the multiplier? 9 by 10. Fine, multiply them. This is what the revenue figures are. These are what the revenue figures are. Just multiply and write under this. Well, these are revenue figures. 45 divided by 40. Alright, you are saying that 45 divided by 40. All right, so first understand the increase here. Therefore, all right, now so when you are writing, this is what, this is the multiplier. All right, because this was a multiplier, this was a multiplier. What was this multiplier? Product of two multipliers becomes what? Another composite multiplier, nothing but a multiplier. But I want a fraction. Increase and decrease is always a fraction, so therefore you write it. So what is the question that you ask yourself? Okay, denominator don't change, numerator how much more? That's a question that you ask. 5 more, therefore 5 more. 5 more means there is an increase. Now look at this, the words are, look at the answer options, there is a decrease as well. There is a word decrease as well. Decrease does not come in the picture, all right, because there is a plus sign. Plus sign means there is an increase. Hey, what is the increase? Simplify this. All right, simplify this, we'll understand. Right, therefore 5 one time, 5 8 time. 1 by 8 is the increase. All right, 1 by 8 is the increase. 1 by 8 increase means what? 12.5% increase. There is an increase. Say, what is the increase? Increase is 1 by 8. Therefore 12.5% is the increase from fraction to percentage conversion. I hope everybody got into the groove of this. All right, everybody who got into the groove of this. Now let me take a look at this. Now the figures are pretty nice. I've intentionally chosen the very nice figures, all right, because I want to bring in another element out here. All right, therefore I've intentionally chosen in both the questions. If you look at it, I've chosen pretty good figures. Now look at the figures. 30%, nice figure I've chosen. Right, nice figure I've chosen. Even if you disagree, I say that they are very nice figures. 30%, 20%, pretty good figures. Right, I've chosen good figures. Reason is what? Hey, whenever, all right, I'm just giving you a mnemonic, a key here. If the figures are good, otherwise don't bother to use them. Otherwise don't bother to use them. It will not make any sense. Right, otherwise don't bother to use, because it will not make necessarily any sense out there. Right, it will not make any sense. Hang on, guys. Yeah, fine, let's take a look at this. Right now, so what I was trying to say was this: if there is, all right, if there is a into b is equal to c, if you have a into b is equal to c, all right, if there is a situation called a into b is equal to c, then what you do is, if a changes, if there is a change, if the a changes by x%, change, remember that word, if a changes by x% and b changes by y%, b changes by y%, then c changes by, given this, these two parts are given, a changes by x% and b changes by y%. If it is given, all right, now so but c changes by, all right, the last portion, right, the c changes by x plus y plus x into y by 100%. It's a simple algebraic proof. Simple algebraic proof. Don't worry about it. Just try and remember this. It's a pretty simple algebraic proof. There is no knowledge. There is no great deal about this. The proof comes from 1 plus x%. You can write this as 1 plus x%, 1 plus y%. All right, yeah. From here you calculate. All right, you will end up at this particular result. But I suggest don't really bother about this right now. If you are good at math and math, the basic, I already gave the hint. Using that hint, you can calculate. Otherwise, don't worry. All right, now because you already know the multiplier method, I'm just adding another method to it just to create that excitement, that hey, yeah, all right, it makes some sense, kind of. All right, now just to create that kind of an excitement. Otherwise, there is nothing beyond that excitement out here. Fine. So what is that here? All right, now look at this. All right, can x be positive? Yes. Can y be positive? Yes. Can one of them be negative? Yes. Can both be negative? Yes. All right, now let's take a look at this particular one. So what was the question out here? All right, now what was the question out here? So a into b, all right, instead of a into b, I'm erasing some portion of this for the convenience of writing. Right, let's take a look back at this. So what is that given to me? Price into quantity that I sell, number of cars that I sell. All it is nothing but the revenue. All right, now therefore it is in the form of a into b is equal to c. All right, a has some name. What is a here? Price. What is b here? Quantity. What is c here? All right, c is nothing but the revenue that person is making. What happened to the price? The price increased by 30%. Price increased by 30%. Okay, what happened to the quantity? Quantity decreased by 20%. Down, the word is down. Quantity decreased by 20%. All right, what should be the change in r therefore? What should be the change in r therefore? Now look at the value of x, friends. X is nothing but 30. Look at the value of y, minus 20. Write it like that. This is 30 plus of minus 20, because the value of y is minus 20, and x into y, that is 30 times of minus 20 divided by 100. Close the bracket. That is the percentage change you are expecting. That is the percentage change you are expecting. Let's calculate this. Let's calculate this. This is 30 here and this is minus 20 here. Therefore, it has become 10. Now look at this. 30 minus 20 is nothing but minus 600. Minus 600 by 100 is nothing but, from here what do I get? Minus 6. That is the percentage that I'm talking about. Therefore, the overall result is nothing but 4%. There is a positive change of 4%. That is what we calculated from here as well. Earlier also we said the same number there. Overall change of 4%. Take a look at the next one. Take a look at the next one. I hope you guys have digested this. Just remember this point. Remember this point. Might come handy sometimes. For a change you can work like this. For a change you can work. Multiplier is my primary tool. No, there is no taking away from that fact. No taking away from the fact that multiplier is my important tool. Sometimes, now for a change, now we also consider a few other methods. For a few other methods, just to create that excitement. Right? Okay. Now look at this. The increase. Now what is happening here? Number of seats. A into B is equal to constant. Similar concept. We are working on the similar concept here. Right? We are working on the similar concept. A into B is equal to constant. A into B is equal to C, not a constant. A into B is equal to C. I am working on the similar concept. Right? Yeah, A into B is equal to C. Right? So what is A here? A is nothing but number of seats. A is nothing but number of seats. What is B here? B is nothing but the ticket price. What is the price per ticket? Price per ticket. B is nothing but the price per ticket. We are talking about price per ticket. So should be equal to what? Should be is nothing but the revenue, sales revenue that is generated. What is happen on yes? Yes is increased. Seats are increased by 25%. What is happening on the price? Price of the ticket is decreased by 10%. 10%. Therefore, what is the change in the revenue? Therefore, author is saying that can you tell me what is the change that is seen in the revenue? What is the change that is seen in the revenue? Change seen in the revenue. How do I write it? We already just discussed this. 25. That is the x value. What is the y value? Minus 10. Therefore, plus of minus 10. Let me write it as directly minus 10. Directly minus 10. Plus of minus 10. Then plus of. Remember, this is 25 times of minus 10 divided by 100. 25 times of minus 1 divided by 100, right? That is the figure that we are talking about. Okay, this leads me to 15%. This is 15. That's a percentage change we are talking about, right? Yeah. And then now look at this. This is a negative value. 25 into 10 is minus 250 by 100 is nothing but minus 2.5. Minus 2.5 percentage, which is 12.5%. Which is 12.5%. That is what we said earlier as well. What is 1 by 8? 1 by 8 is also nothing but 12.5%. One by using the multiplier application. The other one we can also deal it by using, we also deal it by using a, now by also use it by dealing with x plus y, x plus y into xy by 100. X plus y plus xy by 100. We can use this concept as well, only if the numbers are good. Only if the numbers are good. Hey, look, instead if had I given this to you as a 14.28%, 14.28%, this is 6.66%. Oh, please don't do this. All right, now don't use this particular method. Earlier method, multiplier method, is very useful. A 14.28%, 14.28%, all right, increase. Let's say that this increase in 14.28%. Easy to write. Multiplier is 8 by 7. So easy to write. Okay, now 6.66 decrease, easy to write. All right, therefore you will say that hey, this is 1 by 15, right? 1 by 15. Therefore you will say that man, this is nothing but 14 by 15. So easy to write, right? Therefore you will say that man, this is 16 divided by 15. Multiplier is 16 divided by 15. All right, therefore all right, no. So what is the percentage increase? Increase is 1 divided by 15. What is 1 divided by 15? Again, 6.66% is the net increase out here. So it becomes lot more easier to calculate. All right, it becomes lot more easier to calculate. Remember, all right, you got to use numbers pretty properly, right? If the fractions or percentages are not good figures, don't use this. Percentages are not good figures, don't use this. Use this if the percentages are much more convenient to resolve, or much more convenient to work with, right? Now you be mindful about, so multiplier is the primary tool. This is a secondary tool. All right, sometimes for an excitement we use this. All right, it's a secondary tool. All right, don't mix up between the two. Both are same. Right? Okay, let's take a look at this. I'll give a minute for you. You solve this, guys. You solve this. I hope everybody's sitting with a pen and paper. It is not that you are watching something out there. It's a mental gym. Right? In between, after my demonstrations, I will of course give some time for you. So just take a minute, quickly resolve, put the answer for yourself. Yeah, I guess you guys are ready with this. The radius of the circle is increased by 30%. What will be the percentage change in the area of the circle? Now you understand that, hey man, area of the circle, alright, area of the circle is nothing but pi r square. A little bit of geometry. Pi r square. You will understand that pi r square. He's saying that, okay, what will be the percentage change? Alright, what is the percentage change in the area? So he's given the radius change in the radius. There is an increase plus 30%. Radius, there is an increase of 3 by 10. Alright, there is an increase out here. But the point here is, alright, look, listen to that. Pi is not a changing number. Pi does not change, right? Because it's a constant. Alright, of course, pi is irrational. That's another thing. Pi is very, very close to 22 by 7. Pi is not equal to 22 by 7. If you say pi equal to 22 by 7, then any number of the form p by q, where p and q are integers, alright, then that would become a rational number. Therefore, pi is not 22 by 7. Pi is pretty close, very, very close to 22 by 7. For some ease of convenience of calculation, so that we take it as 22 by 7. We take it as 22 by 7. Otherwise, it's an irrational number, right? Pi is an irrational number, all right, which cannot be expressed as p by q. Okay, that's on the other side. All right, I just thought of reminding you about it because it's an irrational number, right? Yeah. So we'll talk more about rationality and irrationality at the later part of the lecture when we do the numbers. Solid. When we do the numbers, we'll talk a little more about it. All right. For now, we will park it aside. So let's go back here. So what I'm interested in, pi is constant. Pi is constant, whether the first case or the second case, pi is constant. Therefore, area is a function of what? Area is technically a function of r and r square. Area is a function of r square, which means it is built upon r square. It is built upon r square. R square is nothing but r into r. R into r. Earlier, you used to have two different numbers. I used to say that, man, already know. So a into b is equal to c. Already a into b is equal to c. Now this time what you are trying to say, you are saying that my a is r, my b is also r, alright, which is nothing but the area. I'm calling this as area. That's what you are trying to tell me. Good. Okay. So what is the first change here? What happened to the first radius? 30%. What happened to the second radius? That's also 30%. Because it's a radius. There is only one radius here. Alright, both have changed by 30%. Therefore, what is the percentage change in the area? Therefore, what is the percentage change in the area? Percentage change in the area is nothing but 13 by 10 into 30. Okay, so we use that earlier application, right? Okay, if you use that second method that we were doing, 30 plus 30 plus 30 into 30 divided by 100%. By 100%. All right, now this is the percentage change, which is pretty simple and obvious, which is 69%. All right, that is the percentage change. There multiplier method right here the multiply method. Multiplier for this 13 by 10. Multiplier for this 13 by 10. Second multiplier 13 by 10. All right, 13 into 13, 169 divided by 100. All right, now so when you are writing the fraction for this is a multiplier 100 as it is. Change here 100 to 69. What is the change? Plus 69. 69 by 100, how much? 69%. Multiplier method. Which method you use does not matter, but if the numbers are not great, of course it's a multiplier method. When the numbers are not good, multiplier method. Numbers are great, already any method that you can do, right? Yeah, so here you might have got some idea about this. Let's take up this example here. When the price of a pressure cooker was increased by 15%, the number of pressure cookers sold decreased by 15%. Find out the net percentage change in the sales. Find the net percentage change in the sales. There is a small last learning point here, and then we'll change the operation to another style. There's one learning point out here. What is happening here? All right, now when the price is increased, all right, the numbers are same. What is the point I'm trying to make out here is the numbers are same, 15% and 15%. The numbers are similar, right? That's a point I was trying to make out here. These two numbers are same. Then what happens? Let's quickly understand. There is a price, and quantity is nothing but the sales revenue. All right, sold. All right, quantity decreased by 15%, price increased by 15%, quantity decreased by 15%. Listen to me, guys. All right, now percentage change. How do you write it? X, that is 15, Y, that is minus 15, plus X into Y divided by 100%. 100%. Right now, this is what you do. So from here, you realize that, man, these two fellows are getting cancelled. Therefore, you are saying that a minus 15 square, all right, minus 15 square divided by 100%. All right, this is the percentage that you are trying to say. All right, now therefore that is nothing but, all right, 15 square is 225 divided by 100. Therefore you are saying that, man, this is nothing but 2.25% decrease, which means there is a loss in the transaction. All right, now there is a loss, which means it has decreased by 2.25%. All right, that is the way that that is what you are trying to tell me. Now listen to me. Hereafter, if you find the same two numbers, all right, if you find the same two numbers, if there is a and there is a B which is equal to C, A changes by X%, and B changes by X%. One of them is positive, one of them is negative, right? If it changes, all right, now once it increases by this and once it decreases by this, but the increase figure and the decrease figure is same, all right, then you will say that the C will change by minus of X square by 100%. X square by 100%. That's what you realized. Finally, that's what you did. All right, why? The reason being that 15 and minus 15 gets cancelled. Therefore, it is good. You can remember this. All right, you can remember this. If the percentage change is same, all right, this is what happens. Now, let me give a simple example here. All right, simple example here. There is a number. All right, the person was getting some salary. There was a person who was getting some salary. First year, he got an increment of 40%. He got an increment of 40%. First year he got an increment of 40%. The next year what happened is this person, he was getting some salary. Next year they decreased his salary by 40%. All right, whatever he was earning S1, they decreased his salary by 40%. Therefore, what is his final salary? All right, what is his final salary? What is the percentage change? Basically, what is the percentage change in his final salary? Now look what happened here. First they increased by 40%, then they reduced by 40%. Therefore, the net change is nothing but 40 square divided by 100, always with a minus sign, always with a minus sign. Therefore, you are saying that, man, this fellow's net salary got reduced by 16%, right? 16%, because 1600 divided by 100. Therefore, this person's net salary got reduced by 16%, right? Now, that's pretty easier. Try and remember this. Then it is easy to apply sometimes. See, these are the small things that you may have to probably remember from percentage, because as I told you, it's a very foundational lecture. Therefore, if you remember these things, probably you'll get the advantage of speed already while you are doing the mental calculation. Because what happens is these small calculations will become a part of your larger picture as you go along, and these numbers will kind of all tick in your mind. See, for example, when you read this 40% increase and 40% decrease, all right, when you read 40% increase, 40% decrease, 16%, all right, now overall decrease just pops up in your mind. You don't have to necessarily pen it down, right? You don't have to necessarily pen it down. You will say that this person's salary got changed by this, then there will be some expenses added to it, there will be some savings added to this, all right, there will be further question built around this particular concept, which we can work it out. All right, therefore just be mindful and make a note of these smaller concepts, all right, which are what I am talking about, because we are going to use these small capsules of these concepts in a mega way as we unleash to the applications in terms of profit and loss and discount, or be it in terms of SICI, all right, because these are the chapters which are built on these particular concepts. We are going to unleash them out there. While we are unleashing these tiny concepts, all it holds a crucial role, all right, they hold a critical role, all right, critical position. Fair enough. Let's go further. Let's go further. Let's go further. Okay, percentage points comparison. Let's understand it. All right, we'll understand in a big way as we go along, but let's understand on a smaller scale. Let's understand this. Let's understand this. Okay, A and B, another concept I'm bringing here, percentage points comparison. Percentage point comparison is nothing but absolute difference between the percentages. All right, absolute. I will explain this. I will explain this, what I meant by this. It's an absolute difference between the percentage figures. That is called as the percentage point comparison. Right, let's take a look here. A and B appeared for a test. A gets 65% marks while B gets 40% marks. A gets 175 marks more than B. Find the total maximum marks scored. All right, let me draw a scale. Let me draw a scale. Say that, okay, we have a percentage scale on one hand. We have a percentage scale on one hand, 0 to 100. 0 to 100%. Say this is the percentage scale. I have another scale parallel to this. I have another scale parallel to this. This is an absolute scale. 0% corresponds to 0 marks. 0% corresponds to 0 marks, and there is a maximum marks which I don't know. All right, which I don't know. What is the maximum marks of the paper? I have no idea. That can be called as X. All right, percentage scale is 0 to 100. That's full. But X can be what? Maximum marks in a paper can be what? Can be 100 marks, can be 200 marks, can be 250 marks, can be 300 marks. It depends. All right, it depends on the university. It depends on the board right now. So what is the maximum marks for that particular paper? If you're writing a CAT paper, the maximum marks so far had been 300 marks, or 100 questions, each question 3 marks. Therefore, it was 300 marks. Therefore, it depends which paper that you are trying to write out there, right? So let's take a look. Let's take a look at this. So now, therefore, A and B appeared for the test. A gets 65% of the marks. Somewhere here on the percentage scale, this fellow is getting 65%. On the percentage scale is getting 65. B gets what? 40%. On the percentage scale, this fellow is getting 40%. Now look, percentage points is nothing but the difference between these two numbers. Difference. I have 65% point there, and I have 40% point there. Hey, what is the difference? The difference is nothing but 25%. What is the difference between them? 25%, right? Percentage scale. On the scale, it is 25%. On the scale, there is a margin of 25%. There is a gap of 25% between them. Now take a look at them. On the other hand, what happened? If you trace it back, what author is trying to say is, look, man, already if you put it back on this perspective, if you bring it here, there is another scale running parallel to this. It's an absolute scale. It's an absolute scale. Other side is an absolute scale. If you bring it back, author is saying this gap here, the same gap, what you talked as 25% here, already is nothing but 175. Alright, that's what he is saying. A gets 75 more marks than B. Alright, now what is that B? What is that? Alright, now what is this? Is what B is getting. This is what A is getting. What is B getting? B is getting till here. Alright, what is A getting? A is getting marks till here. From the 0, A is getting marks till there. Yeah, what is the gap between them? 175. That's a gap between them. What is the meaning of this? 25%. 25% is nothing but 175. Now the question is, I already told you in the last lecture, 25% won't make sense. It's abstract. It's abstract. Therefore, you should always say 25% of what? Alright, now this number, you said that 25% of this scale, absolute scale, because 100% corresponds to X. 25% of X is equal to 175. That's what precisely you are trying to say. Nothing but 1/4 of X is equal to 175. Alright, that is what you are precisely trying to tell me. Therefore, X is nothing but 175 into 4. Right, 175 into 4, which is nothing but, alright, which is nothing but 700 marks. Therefore, this paper was for 700 marks. I hope. Alright, now my point here is, I wanted you to understand the fact, okay, these calculations, etc. were simple. My point, alright, now what is the basic point? What is the point I wanted to make? I wanted to make that the absolute difference between the percentage values is called as the percentage point difference. Alright, that is called as a percentage point difference. What happens at times is, we compare the percentage scale with an absolute scale. There are two different scales running parallel, comparing the percentage scale with the absolute scale, right? That is one point. Okay, let's take one more. Alright, if it is a gray, I will do one more. Alright, this will unleash little better out here. Let's take one more. Take 30 seconds, read it carefully. Read it carefully. Try and get the scales in your mind. Read it carefully. Take 30 seconds. Right, good. Let's do this together. Peter got 30% of the maximum marks in an examination and failed by 10 marks. All right, now this person got 30% and failed. On the other hand, there is a guy called Paul who took the same examination, got 40% of the marks and got 15 marks more than the passing mark. So therefore, we understand that the passing marks lies somewhere between 30% and 40%, because those who got, the fellow who got 40% of the marks got more than passing mark. The fellow who got 30% of the marks got little less than the passing mark, right? Yeah, therefore, now that's what that we understand that the passing mark is somewhere in between. Somewhere in between. The question is, therefore, can you tell me, identify what is the passing mark? So how much is the passing mark? Same way, friends, same way. There is a scale, two scales running out here. So 0%, all right, to 100%. 100%. What happened? One fellow got 30% of the 30% of the marks. 30% of the mark. What happened? The other fellow got 40% of the marks. Hey, what is the percentage point difference between them? 10%. Percentage point difference is 10%. All right. What is happening on the other side of the scale? Let's assume that the maximum marks is X. Maximum marks is X. Let's assume that the maximum marks is X. Now what happened is, all right, now the fellow who got, all right, now there is a passing mark called P in between. There is a passing percentage P. There is also a passing mark in between called as a P. Say this is the passing mark. All right, there is a passing mark called as a P. Now what happened with the first fellow? He got 10%, all right, 10%, all right, 40% of the marks. That is nothing but, all right, 40% is nothing but 15 marks more than the passing mark. Therefore, you are trying to say that, hey, this gap, all right, this gap is 15 marks. All right, this gap is 15 marks. All right, what happened to the another character? All right, what happened to the other fellow is he got 30% of the mark. All right, so what happened with this particular fellow? He got 10 marks, like he failed by 10 marks, which means this gap is 10. All right, this gap is 10. Hey, what is the total gap? Therefore, total gap is 10 plus 15, all right, which is nothing but 25 marks. Let 10 per 15, which is nothing but 25 marks. That is the gap. Hey, what is this 25 marks? 25 marks is nothing but 10%. 25 marks is nothing but 10%. Okay, even if I don't use that x, I can use the proportionality, right? 10% corresponds to 25. 10% corresponds to 25. Fair enough. All right, therefore, what you will say, what does 30% corresponds to? You will understand when I'm doing that. Hey, what does 30% corresponds to? 3 times. It's a scaling proportion, like a zoom factor. All right, you have an image on your mobile, zoom in, zoom out. That's what you do into 3 times. If you do into 3 times, this 25 also should be done into 3 times. 25 into 3, how much? 75. Hey, what is that you are trying to say? You are trying to say that, look, man, this particular number here, all right, this particular number is 75. Till here the value is 75, 0 to 75. That's what you are trying to say. Why? Because 30% is here. 30% means 75. To pass, how much more marks this fellow required? He wanted another 10 marks. Therefore, passing marks is nothing but 75 plus 10. Passing marks is nothing but 75 plus 10, which is 85. Okay, another way to calculate. Another way to calculate. You can start with the same position. I'm just showing you in the same, both the things in the same question out here. Right? Another proposition. What is that? Hey, 10% corresponds to 25 marks. I'm talking the same thing here. 10% corresponds to 25 marks. 15 plus 10, 25 marks. 10% corresponds to 25 marks. Okay, 40% corresponds to what? Scaling factor 4 times. Like zoom in, or let's scaling factor on your mobiles or whatever the images that you do, pretty similar 4 times. Therefore, 40% corresponds to 100 marks. That's what you are trying to say. 40% correspond to 100 marks implies the scale till here. If you take a scale till here, or till here, the 40% figure is here. If you take that scale till here, or let's scale till here is nothing but 100. All right, scale till here is nothing but 100. That's what you said, 0 to 100. You started with 0 onto a point of 100. Hey, how much more marks this fellow got? This fellow got 15 more marks. Down by 15 marks is the passing mark. Down by 15 marks is the passing mark. Therefore, you are saying that passing mark is nothing but 100 minus 15, which is also nothing but 85. Does not matter which way you calculate. All right, whether you calculate from 30 or whether you calculate from 40. Okay, what did I use here? I use the scaling factor. All right, I don't have to necessarily use this x. Instead of using this x, can I use the scaling factor? Yes. You may ask that in the previous question also, could I have used the scaling factor? Of course, yes. Of course, yes, you could have used it. Hey, what do you mean? 25% corresponds to scaling factor could have been used in the previous solid in this slide as well. All it does not matter. So in both those questions that you can use, right? I hope you are able to digest this. All right, I hope you are able to digest this. All right, I'm hoping that you are able to digest this. Great. Let me go further. All right, let me go further. Let me go further. Take a look at this question. 30 seconds of your reflection time. Think about it. Quickly think about it. Same percentage point, similar concept I'm talking about. Similar concept. Yeah, all right. Let's see this. In an election contested by two parties, Party D secured 12% of the total votes, more than Party R. Only two parties, right? And there are no invalid votes unless they say that there are some invalid votes. You don't assume that there must be few invalid votes, right? So unless they mention it, you don't take all it now. You don't bring in the word saying that, hey, what if there are invalid votes here? No, all it now. So you say that, okay, the vote is valid unless it is said invalid. All right, unless it is said invalid, all right, the votes are technically supposed to be valid, right? Now that's what it is. So all right, sometimes you get such doubts while you are doing in the exam. In fact, this was one of the exam question itself, right? Yeah. So therefore, let's see. All right, Party D secured 12% of the total votes, more than Party R. If the Party R got these many votes, by how many votes did it lose the election? All right, if the Party R got this, because D secured 12% of the total votes more, all right, 12% of the total votes more. That's what D has done, 12% more, which means D has necessarily won against the Party R because D secured more. Who secured more? D secured more. Hey, look at this, guys. There are multiple ways to calculate. All right, now one, mathematically, what you will say, D plus R is equal to 100%. Because they together should get 100% of votes. 100% of votes. Of course, 100% of what? 100% of votes. Keep it in your mind. Keep it silent for some time, because every time you don't have to write V. V is nothing but the number of votes being polled. We know that. Now, then what is given? It's also given that D minus R is equal to 12%. D minus R is equal to 12%. Therefore, you will say that D is nothing but 56%. D is nothing but 56%. That's what you say, that all right, D got 56. Therefore, R got the remaining 44%. All right, remaining 44%. That is one way. Now look at this. All right, now these kind of calculations can be done mentally as well. All right, now I'll tell you how. All right, I will tell you how. Assume that D and R both got 50%. All right, assume that both got 50%. That's a time. If D got 12% more, somebody's loss is somebody's gain. This statement is very, very important. We solve a lot of logical puzzles just based on this particular statement. Right now, somebody's loss is somebody's gain, which means the gap becomes 2D, twice the gap. The gap is actually 2D, which D is the loss for somebody. The gain is the gain for the somebody becomes, now gain for somebody becomes 2D. The gap is that. Now that's doubling. There is a concept of doubling there. A lot of people kind of tend to, this is a very, very important concept. In nature also, now sometimes you would have heard this. Now sometimes you would have heard this. Now somebody is some pain, pain and gain, something like that, right? Loss, somebody's loss is somebody's gain, something like this. Now take a look at this. 50%, 50%. All you got to do is what? Hey, if there is a 12%, you just have to remove 6% from this fellow and add it to this particular fellow. Remove 6% from this fellow and add it to this, which means just do half. Just do half of this 12%. You had this 12 here, just do 12 divided by 2. That is the loss for somebody and that is the gain for somebody. Now look at D therefore. Now just look at D therefore. This is 56%. That is what your math said. Right now 50 minus 6, which is nothing. 50 minus 6, which is nothing but 44%. That is what you said here also. 56 and 44. Just remember this. If this figure is 12, simply do half. That is the loss for somebody and thereby that is the gain for somebody. From the mean. What is the mean? Mean means both of them get equal. Therefore, the mental calculation, when I look at this 12, mean comes to my mind. Out of 100, the mean is nothing but 50 and 50. The mean comes to my mind. Once mean comes to my mind, 50 and 50, the mean comes to my mind. I will just look at the deviation. What should be the deviation? By 2. It is 6 is the deviation. Therefore, I will add 6 to somebody. I will subtract 6 to somebody. Or it becomes a mental calculation till there, which means I'm saying that, hey, 56 and 44 should have been obtained mentally. Or it should have been obtained mentally. Don't bother, guys. I'm not saying that immediately you should be able to do. I'm giving these points because while practicing, these are the things you got to keep it in mind to do certain mental calculations. Fair enough. Let's go further. If the party R got these many votes more, technically how many votes more? Party R got these many. Party R got these many votes. How many votes did it lose? Did it lose the election? Who got these many votes? Party R. 44% corresponds to 44% corresponds to 132,000. Simple, friends. Again, the scaling factor, I'm just using this. 44% of what? Total votes. That's what the party R got. Because party R got these many votes, 44% of what? Total votes. But I can make the V silent. I can make the V silent because V is not required. 44% of the total vote, 44% corresponds to 132,000. All right, that's what author said. I'm noting it down. That's what author said. Hey, all right, now how many votes did it lose? How many votes did it lose? In a percentage scale. Now remember the percentage scale. On a percentage scale, the gap is 12%. On a percentage scale, the gap is 12%. They lost by 12% of votes on a percentage scale. This 12% itself, friends. All right, this 12% itself. All right, this 12% itself, whatever you are doing. All right, this is the same 12% we were talking about. This 12%. All right, same 12%. Fine. Therefore, 12% corresponds to what? Because that is the losing margin. All right, that's a winning or the losing margin. Right now, 12% corresponds to what? Simple scaling factor. 44 corresponds to 132,000. I know all of you know how to write this. Therefore, 12% corresponds to what? Percentage is a symbol which gets cancelled. Percentage is a symbol which gets cancelled. Right now, so here, all right, now 11 4 times and 11 1 and 2 times. Solid 1 2 000. That's what you are getting. 4 1 time, therefore 4 3 times. 12 3 times 36. Therefore you are saying that 36 times of 36 followed by 3 zeros. Party, all right, now this party are lost by this particular margin. Okay, fair enough. All right, now this calculation is not a deal. All right, calculation is not a deal. All right, what you need to focus upon is this. 44% corresponds to this. Therefore 12% corresponds to what? That is one point. The other point is what? Somebody's gain is somebody's loss. If you can understand that, you would have got the values 56% and 44% mentally. All right, you would have got these values mentally. All right, that is the learning objective of this particular question. All right, that's a learning objective of this particular question. Okay, here I complete the concept of percentage point. I will turn to the next concept here. I will turn to the next concept, another important concept. All right, for quicker calculation perspective, it is one of the important concepts. Let's take a look at this. Let's take a look at this. Okay, so what is it trying to say? If A is 25% more than B, all right, now it's the importance of keyword than. All right, in my first lecture, I briefed you about the importance of keyword of. All right, I briefed you about importance of keyword of from the percentage perspective. Of course, of had its importance in. All right, of had its importance. All right, even in BODMAS. All right, while writing the BODMAS. All right, B stands for various types of brackets. O stands for of. Similarly, all right, there I talked about the importance of there. All right, that's a direct comparison of two numbers. The value what comes immediately after of should come in the denominator. That is what I updated you there. So here, let me talk about the importance of than. Let me talk about importance of than in this scenario. Now listen to me carefully, friends. Listen to me carefully. Now here, all right, now this is the information. A is 25% more than B is an info. This is an info. All right, this is an information. Okay, B is what percentage? Now look at this. B is what percentage? This is the question type. So what is that author is trying to say? He's saying that, look, man, I have given you some information and I'm asking you a question. All right, if you look at the first part, the author is saying that I'm giving you some information. Now I'm asking you a particular question. Can you answer that? All right, that's a point author is trying to make. Now listen, whatever comes after than is two important things. Now in percentages, most of your teachers would have said right from your class 6 or at class 5 or class 6. Class 5, all right, class 4 is when you hear about the percentage for the first time. Class 5 is when you start working a little bit on the percentage, right? Yeah, so percentage, when you look at the percentage out here, class 5, right, percentage 25% more, all right, 25% more than B. Whatever comes after than, you have to make the assumption. Assumption also should be done what comes after than in the information. All right, you will never make the assumption in the question step. Assumptions are not made in the question step. Assumptions are made in the information. Convenient assumption can be made. Why? If B is 100, all right, B is 100, 25% more is easier. 25% more than 100. 25% more than 100 means 25 more itself. Therefore, the resulting number becomes 125. What did I get? I got the dummies. The dummy value of A is 125. The dummy value of B is 100. Now look at this. What the second point? Assumption should be made after than. Whatever comes after than in the information, you can make an assumption. Even in any question that you read, if you are forced to make an assumption of 100 or whatever that you want to make an assumption for the number which for the variable which comes after than. All right, what comes after than? That's where you got to make the assumption. Second point, when you go to the question stem or whatever, what should be in the denominator? Whatever comes after than should be in the denominator. Whatever comes after than should be in the denominator. Guys, I'm not stooping down to the class 5 level. I'm quickly giving you the mnemonic because in the percentage 1 lecture, I wrote that particular statement. I wrote the equation for it. Then from there, I told you that whatever comes after off should come in the denominator. Here, I'm taking it to you directly because already we are at the next level here. Therefore, I'm dealing with this part directly there. Whatever comes after than should be in the denominator. What is in the than then? A is coming after than in the question stem. Therefore, that should be in the denominator. Look at the question stem. What is coming after than A? That's in the denominator. What should be in the numerator? Less. Less should be in the denominator. B is less. Solid B is less. B is less means what? A minus B. All right, how much B is less? All right, how much less? 25 less. That is nothing but A minus B into what? 100. That is the required calculation. Let's go there. What is all right now? What is A here? Dummy value of A 125. Dummy value of A is 125. Hey, what is the difference between these two numbers? Of course, this itself is the difference. Difference is 25. All the difference is 25. What is the fraction equivalent? Fraction equivalent is 1 by 5. What do you mean by 1 by 5? 20%. I don't need this 100, right? It's a black box. We learned that in the first class itself. We don't need that 100. Fraction, if I get, we know how to convert it to percentage. From fraction, we can directly rock onto the percentage. Therefore, what matters is only this portion. Only this portion. Therefore, you are saying that, man, this is 20%. All right, that what stands for 20. Therefore, you are saying that your answer B is 20% less than A. If A is 25% more, B is not 20% less. It's not 25% less. It is 20% less. It is 20% less. Let's do one more like that. Let's do one more like that. Then we will see the learning objective from here. Let's do one more like this. Info. All right, here is my info. All right, here is my info. What is coming after that? B is coming after that. Take it as 100. All right, take it as 100. All right, A is what percentage more? No more, 40% more. 40% of 100 is 40 itself. See, idea of telling B is equal to 100 is what? Calculation of percentage becomes easier. 40% of 100, nothing but 40 itself. Therefore, A is 40 more. A is 40 more means the dummy value of A becomes 140. I'm ready with the dummies. The dummy value of A is 140. The dummy value of B is 100. What is coming right after A? All right, what is coming right after than? It is A. Therefore, A sits in the denominator 140, because right after than what is coming, A is coming. What is the dummy value of A? 140. Okay, what I should write? Less I should write, not B. B is how much less? That is what I need to write. Therefore, how much less? This 40 less. All right, 40 less, that's what you said, or 140 minus 100, therefore 40 less. Technically, fraction form is what? 2 by 7. Percentage form is what? 28.57. 28.57. Simple one. All right, now because we understand fraction, percentage, equivalent. Okay, now you might have got some idea about this. Now listen to me carefully, friends. Listen to me. How do I compare? Basically, I'm talking about comparison of two values. How do I compare them? There is an info and there is the other side of it. Now listen, all right, now listen to this carefully. This can be done mentally, provided you learn the way that I'm going to do it now here. So there are two sides. All right, there are two sides. There is a side of A, there is a side of B. Let me put it like this. Increase. All right, there is an increase in some value is given, then the decrease is questioned. Increase is given and the decrease is questioned. Listen carefully. All right, increase is given, decrease is questioned. All right, from increase to decrease. Increase is given, decrease is questioned between the two values. What are the two values here? A and B. I'm comparing A and B. Now look, all right, now how much more? Listen to this. All right, how much more? Look at that value. How much more here? First question, 25% more. Write the fraction equivalent of 25% more. More means put the plus sign. Put the plus sign. 25% is nothing but 1 divided by 5. That is the 25% more. 25% more is nothing but, sorry, 1 divided by 4. 25% more. All right, 25% more. My mind is already calculating answer. That's why all right now. So mind is running faster than what the mouth is speaking. Right now, therefore, that 5 is supposed to be coming later. It has already come out here. You will understand in a while what I meant. Right now, increase is 1 by 4. The decrease. Now listen, it is opposite of multiplier. The way you use the multiplier, this number works in the opposite manner. What do you do? Numerator, don't change it. Numerator, don't change it. All right, what you do is change the denominator. All right, change the denominator. What is that? 4 plus 1. What is 4 plus 1? 5. Write it here. What is 4 plus 1? Change the denominator. Which means if the increase is 25%, if you have written increase is 25%, the decrease is going to be 20%. That's what you got earlier also. Earlier also you said 20%. Simple. All right, now write it like this. So I will give the mnemonic here. What is that I'm trying to do? If the increase is of the form x by y, if the increase of the form x by y, then the decrease will be of the form x divided by y plus x. Don't change this x. All right, don't change this x. Retain the numerator as it is. Only the denominator you add and change. Add these two fellows and then change it in the denominator. Add these two fellows and then change it into the denominator. Hang on. All right, and then change it into denominator. Right, change it into denominator, that is x plus y. I hope all of you got this, what I'm trying to do here. Look at the second question. 40%. A is 40% more. All right, the second one 40% more. Right under more here. 40% is nothing but plus 2 by 5. That is 40% plus 2 by 5. Right now, then you are saying that okay, so it has to decrease by what percentage? All right, therefore B is what percentage less? B is what percentage less? We know the answer is 28.57%. Simple, guys. This 2 as it is. Don't change this 2. Don't change this 2. Write this 2 as it is. Don't change this 2. What to change now? 5 plus 2. What is 5 plus 2? Change the denominator 7. That's what precisely you got here. 2 by 7. 2 by 7. And you wrote this particular number. And that's what we are doing here. Now, therefore, listen to me. Where this question comes handy, where this application comes handy, I hope all of you understood this and noted this down. I'm removing this. All right, now, so where does this come handy? Let's understand. Where does this come handy? These numbers were comfortable. Where does this come handy? So if you say that A is, say, if I write the number, A is 14.28% more than B. Oh, now it looks like a dirty number. Instead of this 25, if I write it as A is 14.28% more than B, fine. If I start with my first approach by saying, hey, this is 100, then this A will become 114.28. Nobody likes this. Hey, what is this 114.28? And then I will, all right, how do I calculate based on this? All right, this is where you will say that, hey, these fraction approaches are always useful. That is where I give importance to these kind of fractions. All right, that's where I give these importance. Now look at this. Had I known this part, let's assume, had I known this particular part, increase, decrease part. All right, increase, decrease part. We said that increase, if it is of the form x by y, decrease will be of the form x divided by y plus x. That is what the corresponding decrease will be. So now look at this 14.28. Very easy to write. What is 14.28? 1 by 7. Hey, what is the answer? Retain this 1 as it is. Add 7 plus 1 and write in the denominator 1 by 8. Therefore, you will say that, man, how much percentage less? In that case, B is going to be 12.5% less. Very easy to answer. All right, very easy to answer. That's our advantage. That okay, instead of this 40%, let's say that instead of this 40%, if I have all right now, if I have a particular number here, all right, which is which is 37.5%. Let's take 37.5%. It might not look very familiar. All right, you write 100 here, and then you will write 137.5. You might not like this. Easier way to write is what? What is 37.5%? 37.5% is nothing but 3 by 8. Hey, what I should be writing here, therefore 3 as it is. What is 8 plus 3? 8 plus 3 is nothing but 11. All right, therefore you will say that my answer is 27.27%, because we know what is 3 by 7. All right, from the previous chart we already know this. Okay, I hope all of you are getting this. Now what I do on the second side is, now look at this, less is given, info, less is given. Opposite of this, in the information, less is given. What is being asked? More is being asked. Less is given and more is being asked. Hey, what do I do under such circumstances? What do I do under such circumstances? Let's understand. If the less is given or decrease, less or decrease, whichever way you say, all right, less is given and the more is question. And the more is question. Let us say that if the less is of the form P by Q, if the less is of the form P by Q, write the fraction value of the percentage. If the less is of the form P by Q, less of the form P by Q, then more will be of the form, retain this P as it is, friends. Don't change the numerator here. Retain this P as it is. Then Q minus P. More will be of the form Q minus P. Retain that P as it is. Change the denominator. In the multipliers, you used to change the numerator. All right, now here in this technique, you are changing the denominator. All right, now kind of opposite. You retain the numerator. Now take a look at this question. 25% less. Write it here. 25% less. Minus of 1 by 4. 25% less. Hey, how much more therefore? The more is going to be 1 as it is. 4 minus 1. 4 minus 1 is 3. Therefore, you are saying that okay, B is 33.33% more. All right, B is nothing but 33.33% more. All right, of course, the traditional approach I already taught you. Hey, this is 100, 25% less. Therefore, all right, this is 75. That's a traditional approach. I'm not saying no to the traditional approach, but if the values are not nice, the traditional approach, all right, now may become a little bit of a that may become a little tedious to calculate. Therefore, I'm saying that for us, the percentage means fraction, fraction means percentage. That's how they embrace each other. All right, that's how these two things embrace each other, right? That's a point I'm trying to make here. Fine, let's take further. Let's go further here. 40% less. The word is 40% less. Hey, what is 40%? 2 by 5. All right, what is 40%? 2 by 5. All right, 2 by 5 less. What I should do? 2 as it is. Don't change this 2. Write this 2 as it is. 2 as it is. Then what we do? 5 minus 2. All right, then what we do? 5 minus 2. All right, then we do 5 minus 2. 5 minus 2, what is 5? Well, then we do 5 minus 2. Sorry. All right, then we do 5 minus 2. What is 5 minus 2? 5 minus 2 is 3. All right, therefore you say that, hey, this is nothing but 66.66% more. Therefore, in that case, B is going to be 66.66% more. I hope all of you are getting this right now. So what is the learning point? I want you to remember these areas. I want you to remember this. I want you to remember this. We'll see the application in a while. I want you to remember this. All right, because this helps us to do the mental calculation. When the increase is given, comparing two quantities, comparison. What is the heading that I'm doing? I'm comparing. How do you compare two quantities? Whenever two things are there, how do you compare? Right? If one is so much more, then the other one will be what percentage less? All right, these two boxes I want you to remember. Take a special care or a special note of these 2 points. All right, special note of this. Special note of this. Okay, try and digest them. Try and digest them. Let's do the applications in a while. Try and digest them. I guess nobody has any questions. I guess these things are clear the way we are trying to work out. Right? I'm assuming that the things are clear to you. Concepts are lucid from black to gray to white. Okay. Great. Here we go. Fine, let's see applications. All right, let's see some of the applications. If the price of petrol increases by 20%, by what percentage its consumption should decrease to keep the expenditure same? Now listen to this, friends. Listen to this. I want all of you to listen to this carefully. One of the applications of this particular tool, I'm directly getting onto the applications of this. One of the applications of this particular tool is when A into B is equal to constant. not a into b into c is equal to constant. Only when a into b is equal to c, all right, which is nothing but constant. Earlier we did this, a into b is equal to c, precisely the same thing. A into b into is equal to c, in which c is constant, in which c is constant. That is when you can use this. Practical applications comes handy here. Whenever a into b is equal to c and this c is constant, that is when I can use the right, that is when I can use the increase decrease. Now look at it, obviously, right? If a into b is equal to constant, if a is increasing, naturally b has to decrease. All right, b has to decrease. All right, that is when product will be constant. You can't say that a value of a is also increasing, value of b is also increasing, yet c is constant. Oh, that's a miracle in math. That is going to be a miracle in math. That's not going to happen. If the value of a is increasing, naturally value of b should decrease. Otherwise, vice versa. If the value of b is decreasing, then the value of a has to increase. Now this is where I'll do the percentage calculations here. Now listen to this particular question. This is where you can use this hand. You can use this tool handily. Don't get confused. All right, sometimes it looks like an information overload because I tiny. I did about 5 points by now, right? So therefore it looks like, hey, this is becoming little too much, becoming confusing. Don't worry. When you go back, all right, now take a revision, take a look at this particular note once again. We'll listen to this video once again. Things will be clear. You will be able to package them properly. I'm taking each concept, I'm giving them back. So therefore, all right, now, so all you do is you just put them in the packages or in your memory cells, put them properly so that retrieving becomes easier. It looks like confusing at times because all right, it looks like sometimes the information overload into your mind, right? Otherwise, you put them in partitions carefully and clearly. It will not be any already. There'll be a declutter. There will not be any clutter. You will be easy to recall and you will be able to apply to the right kind of questions. All right, yeah, let's take a look here. Let's take a look here. What is this particular question? The price of petrol increases by 20%. By what percentage its consumption should decrease to keep the expenditure constant? Now look at this beautiful question. So what is that? Price of petrol into the quantity that you fill is nothing but your expenses. You're nothing but your expenses. Nothing but what? A into b is equal to c, in which the c is constant. In which the c is constant because the author he's saying that expenses should be same. Hey, I don't want to change my expenditure at all. All right, because the petrol is increased. If the petrol is increased, I will reduce the quantity. I will reduce the quantity that I consume, but I don't want to change my budget for petrol for that particular month or for that particular day. I'm not going to change my budget. Expenses are going to be constant. All right, that is what he said. Expenses are going to be constant. Now look at this. What happened on the price increase, or what happened on the price here? Price increased by 20%. Price increased by 20%. Hey, what should happen to the quantity here? Decrease. Now he's saying that, hey, therefore, what is the percentage decrease? That's what author is questioning. Therefore, my increase decrease tool will come in the handy, friends. Increase decrease. Increase decrease tool. Increase decrease tool will come in the handy. 20% increase. What is 20%? All right, now plus 1 divided by 5. All right, what is the decrease? I should write 1 as it is. 1 as it is. 5 plus 1, 6. All right, this is the quantity that you have to reduce, which means your quantity, your consumption should get reduced by 1 by 6. Hey, what is 1 by 6? 16.67%. All right, now consume less by 16.67%. Consume less, which means whatever the quantity that you are buying before, whatever the quantity you are buying before, reduce it by this much. I'm not using the minus sign because already I'm saying that it's a reduction. All right, author only use the decrease by what? All right, I'm saying that you got to decrease your consumption by 16.67%. Don't panic. If the price increases by 20%, don't panic and reduce your consumption by 20%. Reduce by 16%, you'll be able to maintain your expenditure. That's the application of the tool that we learned. We learned a tool and this is how the application looks like. Okay, let me take one more. All right, it looks great. Let me take one more. All right, let me take one more. It's very easy. Let me take one more. Let me take one more. Now listen to this. All right, now what is the author is trying to say? Length of the rectangle decreases by 37.5%. By what percentage the breadth should increase to keep the area same? All right, there is a length and breadth to this particular rectangle. You promise some land. This is the length and breadth. But for some reason you are saying that, hey, length I am going to decrease. Length I am going to decrease. Sure, if you decrease the length, you increase the breadth, but give me the same area. Same area. Now look at this. This is also of the form same concept. A into B is equal to C, where C is a constant. All right, where C is a constant. What is A here? Length of the rectangle. What is B here? Breadth of the rectangle. What is C here? Area of the rectangle. The author is saying that area of the rectangle should be constant. Whenever the product of two elements is constant, all right, that's when I can use the increase decrease concept. What happened to the length here? Decreased. Fair enough. This is decreasing. Decreasing by what? 37.5%. So naturally the breadth has to increase. Increase by what? Some x%. That's what I author want is to calculate. What is this x man? Therefore by what percentage should calculate? So again we know the decrease increase tool. All right, we know the decrease increase tool, decrease to increase tool. What is decrease? 37.5%. What do you mean by 37.5%? Minus sign. Keep that minus sign in mind. 3 by 8. Now retain the numerator as it is. Don't change this fellow. Don't change. 3 minus 8 is nothing but 5. What is 3 by 5? 60%. You are saying that your breadth should get increased by 60%. Increase the breadth by 60%. That is when the area remains constant. Listen to me, friends. After some time, these things will run right in your mind, because when you see 37.5, this 3 by 8 runs in your mind. The minus sign also will be there. You will retain that 3 as it is. Simply you will do 3 minus 5, 3 minus 8 minus 3 in your mind. You will get this value mentally. Trust me, it's a matter of time. Already you will be doing these questions. You'll be doing these questions mentally. Trust me, you'll be doing it mentally right now. So here, all at the institute, all in Endeavor, at Endeavor, we also have that as a toothpick test. What do you mean by toothpick? We will not give the pen and the pencil. All right, we'll not give the pen and the paper. Rather, we'll give a question paper with about 20-30 odd questions, right? Then we'll give a toothpick. Yeah, literally toothpick. I'm talking about the toothpick, as you might be knowing, right? Yeah, we give the toothpick and we'll say that do it mentally, which means you read the question, you do the calculation mentally, and you will punch it using the toothpick. You'll punch that answer. All right, there will be 4 answer options, A, B, C, D. All right, you think that the answer is 60%. 60% will be one of the answer options for this question. You'll punch it using that particular toothpick, right? Fantastic, right? This is how you practice some of the mental calculation. We do a couple of papers like that, and then we will leave it to you. We will leave it to you, because every time I don't have to give you a toothpick and a paper and ask you to punch. That's not the idea there. See, it sets the momentum. Once it sets the momentum, you got to carry on. You got to carry on with your mental calculations. I'm not saying that you have to carry on with a toothpick and a paper. That's not the idea. Idea is to illustrate, to get it that, hey, you are capable of doing mental calculations. Please do them, because the mind can work faster than what you can express on the paper or on the via voice. The mind can work much faster. That's the whole idea of that. Fair enough. Let's go further. Let's go further. I hope my illustrations are coming out coming out clear to you. Let's take a look at this. A person generally travels between A and B with a constant speed. If he increases the speed by 28.57%, then by what percentage of travel time he will save? Now look at this again. Now most of you would be knowing about this. Speed into time. Speed into time is equal to distance. The speed with which the person has traveled, average speed with which the person has traveled, and the time for which this person has traveled. It is nothing but the distance covered by this particular person. What did author say? This is constant. This is constant. This is constant. Generally travels between A and B. Distance is constant, because he's not saying that, hey, one day I will travel between A and B, one day I will travel between B and C. No, he is not saying that. That is constant. He travels with a constant speed, which means it doesn't change the speed. It's not that, okay, sometimes I will zoom at 20 kilometers per hour, sometimes I will go as slow as 20 kilometers per hour, hey, sometimes I will increase my speed to 80 kilometers per hour. No. He decides some speed and he sticks to that speed. That is called as constant speed. Constant speed means one day. On day 1, he decides that let me drive at 30 kilometers per hour. Day 2, he may decide that let me drive now at 40 kilometers per hour. The other day, he may decide that let me drive today coolly at 20 kilometers per hour. Maybe. So different things. Right now. So therefore, that's what you mean by constant speed. It is not that the part of the journey he travels at 20 kilometers, another part at 80 kilometers. No, that's not the word. The constant does not mean that every day it remains same. On one particular day, he travels with a constant speed. That's a meaning there. Okay, so what is constant here? The distance is constant, because he's traveling every day between point A and B. That distance remains constant, right? Yeah, okay, fine. Let's go further. If he increases the speed by 28.57%, he has some original speed. He's increasing it by 28.57%. Good, 28.57%. So naturally, he will save the time. Naturally, he is going to save the time. It's in the percentage. Then by what percentage of travel time he will save? Of course he will save. If he's traveling faster to travel the same distance, naturally he is going to save the time. Let me do it here itself, friends. Let me do it here itself. Plus 2 by 7. Plus 2 by 7. 2 as it is. Don't change this 2. Don't change this to 7 plus 2, which is not 7 plus 2, which is nothing but 9. So he is going to save, now 2 by 9th of the time. That is, he is going to save about 22.22%. That is the amount of time that is going to save. Whatever the time this fellow was taking, he is going to save this much more time. 2 by 9th of the time is what he's going to save. I hope it's making sense to you. It's making sense to you here. It is making sense to you. Let's take now one of the exam applications. Now, so it should be clear. Let us take one of the exam applications. How do I put a lot more words to this? Little more practical. Let's make it a little more realistic. Let's put some words to this. Now look what has happened here. The reduction of 20% in the price of the sugar enables a customer to obtain 2 kg more Well, 2 kg more, what 2 kgs more of sugar for rupees 480. His budget is fixed. What author is trying to say is his budget is fixed. He spends 480 on sugar every month, or maybe already every quarter, whichever. Already the duration we don't know. Already this person's budget, whenever he goes to buy sugar, he buys it for 480 rupees. Already that's what he buys. Already now, so irrespective of the prices, one day the price reduced by 20%, therefore he got 2 kg more. Already he got 2 kg more. Hey, what if the price increases? He will buy less, but the budget is fixed. He will go and say that, hey, fill it, or fill or give me sugar for 480 rupees. That's all he's going to say. Now his question is, find the original price of the sugar. So which means, what was it before? Now it got reduced by 20%, correct? What was it before? That is the author's question. Now look at this. What is that we are trying to say here? Price into quantity is equal to amount. All right, price into quantity is equal to amount. Amount is constant. What is that amount? Amount is constant, which is 480 rupees. Amount is constant. Hey, what happened here? All right, now the reduction of 20% in the price. Price got reduced by 20%. The price got reduced by 20%. Fair enough. All right, now price is reduced. If the price is reduced, the quantity is going to increase. Let me find out the quantity, guys. Hey, if I'm writing, all right, now, so here, all right, now, why I took this kind of question is to bring the clarity. When I meant 20% reduced, 20% of what? 20% of P. All right, whenever I'm saying that it got reduced, look, all right, now, so I'm taking few things for granted while I'm doing, because percentage is abstract. When I write 20%, don't think that, oh, what is this 20%? Of course, 20% of something. 20% of what? 20% of whatever the earlier price that was. All right, remember that variable is there, but that was not required while I was illustrating that concept. But these numbers are at the back. They're just like you knock at the door, I say, come on, swift, come in. Of course, come in. In is there, but sometimes more often than not, we don't say in. We'll say just come. All right, similarly, I say that, okay, 20%. Now you should understand, when I'm writing 20% below P, I mean that, hey, it is 20% of P. You cannot leave 20% hanging out there. 20%, no, 20% of what? 20% of P. At times I will leave it to you. I leave it to you, just like come means, of course, come in. Somebody knocks at the door. Similarly, when I write 20% under P, interpretation is clear that it is 20% of P. Good. Okay, let's write the fraction here. 20%. 20% is 1 by 5. All right, 20% is 1 by 5. Therefore, Q has to increase. Q has to increase by X%. All right, Q has to increase by X%. Sure enough, hey, what is the increase therefore? Increase is, keep this one as it is. Keep this one as it is. 5 minus 1. What is 5 minus 1? 1 by 4. You are trying to say that, all right, the Q is going to increase by 25%. Q is going to increase by 25%. My question is 25% of what? 25% of Q. What is this Q? Initial value. P was the initial value, initial price. What was Q? Initial quantity. All right, that's nothing but the amount, which is 480 rupees. All right, therefore that is Q. So therefore, hey, what is 25% of Q? 25% of Q is nothing but 1/4 of Q. That is the increase. Hey, what is this increase? This increase is nothing but 2 kgs. All right, that's an increase, because plus 25%. You're saying plus here, plus X%, plus 25%. How much more? That is more. Plus means more. How much more? 25% more. 25% fraction form is what? This itself. All right, 1 by 4th only. 1 by 4th of what? The quantity. Q only. Q is the earlier quantity. 1 by 4th of Q is how much? 2 kg more, because it's more. Plus means more. That what is that more part of it? 2. Hey, therefore, what is Q? 1/4 of Q is equal to 2. Therefore, Q is nothing but 8. Therefore, Q is nothing but 8. That's what you are saying. Quantity is nothing but 8 kgs. All right, quantity, earlier quantity was 8 kgs. Now, can I find the price? Of course, yes. All right, this gentleman was buying 8 kgs. This gentleman was buying 8 kgs for 480 rupees. All right, for 480 rupees. Therefore, you will say that the price is nothing but, all right, price is nothing but, all right, now the amount, that is 480 rupees, divided by the quantity, which is 8. All right, therefore, price is rupees 60 per kg. All right, rupees 60 per kg. That is the price. That is the earlier price. All right, that is the earlier price. Hey, what is the reduced price? Can I find out P dash? What is the reduced price? Of course, yes, 20% is the reduction. 20% is the reduction. I will give 20% discount on this. All right, if I give 20% discount on this reduction, reduced by 20%, recovery is how much? 80%. What is 80%? 4/5 of 60. All right, 4/5 of 60. All right, therefore the reduced price is 48 rupees. That's the reduced price. Earlier price is 60 rupees. The revised price is 48 rupees. All right, there, based on the revised price, you get 2 kgs more as well. Okay, that's the meaning of this question. Let's do one more. Let's do one more. From black to gray to white. Let's do one more. All right, things will become much more lucid and clear. I took enough time to explain this. Nevertheless, let's take one more here. Let me take one more on the similar concept. Similar concept. Read it. Take 30 seconds. Read it carefully. Read it to yourself. Yeah, let's try this. All right, due to increase in the price of petrol by 16.66%, a person gets 1 liter petrol less in a budget of rupees 420. That's his budget. All right, his budget is 420. All right, now for how many days or whatever, all right, his budget, whenever he goes to the fuel station, he fills fuel for 420 rupees. That's a budget. He says that fill it for 420 rupees, right? Yeah, that's a budget. What happened? The petrol price increased. Petrol price got increased. Therefore, naturally, all right, now he will be buying less. Naturally, he'll be buying less. How much less? 1 liter of petrol less. That's what he's buying here. All right, therefore, he's saying that find the original price and also the current price. All right, current price, of course, the original price means initial price, that was less. Current price is more because it has increased by 16.66%. It has increased by 16.66%. By now you would have got the answer right in your mind itself, right? So let me do it here. So therefore you are saying that price into quantity is nothing but the amount, which is 420, which is constant. All right, which is 420, which is constant. What happened to the price? Price increased by 16.66%. All right, 16.66% of what? Earlier price, P only, right? That is nothing but P only. 16.66%. What is 16.66%? 1 by 6. All right, what is this? 1 by 6. Hey, what happens to the quantity? Therefore, naturally, the quantity will decrease. All right, quantity will decrease. Let me write in the fraction form. All right, what is the decrease? Therefore, 1 as it is. 6 plus 1 becomes 7. The quantity will decrease by 1 by 7. A 1 by 7th of what? It's a decrease, right? Yeah, 1 by 7th is the decrease. Of course, there is a minus sign here. I'm not writing minus sign here because we know that it's a decrease only there, right? Yeah, 1 by 7th is the decrease. 1 by 7th of what? 1 by 7th of this q. Otherwise, you can't leave that q hanging, 1 by 7th hanging there. 1 by 7th of what? Something you should write. 1 by 7th of q is nothing but 1 liter. Why? Because author only said 1 liter less. He gets 1 liter less. He gets x% less. X% I can convert. I can say that minus 14.28% because 1 by 7 is 14.28. That's not required. That's not required. It's not required. 1 by 7th of q is equal to 1. Therefore, q is equal to what? 7 liters. Q is equal to 7 liters. Cross multiply. Q is nothing but 7 liters. That is what he used to buy before. All right, that is what he used to buy before. So I know that what is the price? Price is 420. Right now, earlier price, P is equal to 420 rupees he used to spend. And then he used to buy 7 liters. Right, 7 liters. Therefore, rupees 60 per liter. Rupees 60 per liter. Right, yeah. So the rupees 60 per liter. So what is the revised price? What is the revised price of this? Revised price is 420 divided by 6. Hey, why 6, man? Because he's buying 1 liter less. Earlier he used to buy 7 liters. Now it is 6 liters, 1 liter less. Therefore 420 divided by 6. Therefore now it has become rupees 70 per liter. All right, now it has become rupees 70 per liter. I hope it made sense here. All right, it made complete sense and you are getting into the groove, I guess. I guess everybody is getting into the groove. Okay, a little more time, right? Another 10-15 minutes, we are done. All right, now, so I will update you with one concept out there. All right, now one last concept, equating the constants, pretty important concept. I will update you with one concept and we are done with this last concept. Maybe about 15 minutes. As I keep telling you, the last, when we reach the end of the lecture, there is always fresh release of energy. Trust me, it happens even to me. I'm also human like you, therefore it happens even to me as well. When I know that, hey, I'm teaching the last concept of the day, all right, I also get the fresh release of energy because I know that my activity is going to change after this. It might not be necessarily the end of activity. Where is the excitement? The excitement is change in activity. All right, change in activity because we're continuously doing the same activity for about a couple of hours. All right, therefore, all right, now, so change of activity. All right, now, so creative mindsets, right? As a creative people, we always want to change some activity there. All, of course, change it for good, right? Yeah, nevertheless, all right, now let's see that. All right, let's see this. So last concept, last 15 minutes, completely focus, important concept as well, right? Very important concept as well. Let's understand what do you mean by equating the concept. There's a concept of equating the constants, equating the constant. Let's take a look at this question. Beautiful question. Fresh grapes contain 80% water. Dry grapes contain 20% water. Right, water. All right, now water is getting evaporated. It's a process. All right, this is a process. They evaporate the process. They take the fresh grapes, they take to the production unit, and then they will evaporate some water. Thereby, they make the dry grapes. Dry grapes is not solid. All right, it is not a solid, completely dry like a powder types. No. All right, it has 20% water. Nothing but raisins. Technically, you can say that somewhere closer to raisins. Yeah. How many kg of dry grapes can be obtained from 60 kg of fresh grapes? Now, this particular manufacturing unit started with 60 of fresh grapes. What is the end result? Now look at this. There are two portions to this. All right, there is a water portion to this. If you take a grape, all right, let's take a grape here. Well, let's take a grape. What I'm trying to say is this. All right, there is a constant portion. All right, if you take a grape here, All right, you take grape. There are two portions to this. One is the water portion. All right, there is a water portion and there is a dry portion to this. Nothing but a pulp. Let me call it as a pulp. Let me call it as a pulp. Pulp is the dry content. There is no water. Let me call it as a pulp. Pulp also has a little liquid content in it. Call it like that. All right, there is a pulp. There is a water portion and there is a pulp portion. What is the pulp portion? Dry portion. That is not going to change. If you put it to the sun, assume that that's a dry portion. All right, now pulp is nothing but the non-water. Basically, pulp is nothing but non-water. What I'm saying is, man, this is the non-water component. This is the non-water component. This won't get evaporated. What get evaporated is water. Thereby, all it from fresh grapes, I will get the dried grapes or nothing but the raisins, somewhere closer to the raisins. All right, I'll get a kind of a raisins. Now look at the case one, initial case. Now look at the initial case. What is happening in the initial case? In the initial case, the grapes has 80% water. Look at the initial case. You took some grape here. In the initial case, the grapes has 80% water. Call it 80%. 80% of what? Initial. Let me call it as I, friends. Let me call it as I. I might be writing 80%, but be mindful. 80% of what? 80% of I, initial quantity. You started all it. Now you brought some grapes into production, fresh grapes into production. Let me call it as I kgs you brought into the production of fresh grapes. 80% of them is water. Therefore, how much is the pulp? 20%. 20% of what? I. Let me write it I if you want. 80% of I and 20% of I. Let me go to the finished product. Let me go to the final product, finished product. What happens on the finished product? All right, now the dry grapes contain 20% water. All right, 20% water. They contain 20% of the water. That's a finished product. Finished product has 20% of what? 20% of F. Therefore, what is the pulp? Pulp is the remaining 80%. 80% of F, because if the 20% is water, then what is the remaining 80%? That's a question. What is the remaining 80% pulp? Because 20% is water. Here 80% is water. Therefore, how much is the pulp? 20% is the pulp. 20% is the pulp. Now pulp did not change. Now focus on this. All right, this is what I want you to focus upon. That's it, and the problem is over. This is all I want you to focus upon. Pulp did not change. Whenever you brought the grapes into the manufacturing unit, the same amount of pulp is there even after you get the finished product. All right, even after finishing that particular product, the pulp did not change. What changed is the water content. Therefore, what? These two are equal. All right, therefore these two are equal. That's what you are trying to say. What is that you are trying to say? 20% of I is also equal to 80% of F. Why? Because that is the pulp. Pulp did not change at all. Whatever the pulp was available in the fresh goods, all right, the same pulp is available in the finished goods. Same pulp is available in the finished goods. Therefore, these two quotients are equal. That's what you mean by equate the constant. Hey, there is something which is unchanging. There is something which is unchanging. Constant here. There is something which is unchanging. That's pulp. Equate it and you are done. Therefore, you will say that what is I by F? Initial quantity by the final product. All right, what is the ratio of I by F? I by F is in the ratio of 4 by 2, 4 by 1. All right, that is 21 times. All right, this is 24 times. All right, the I by F is in the ratio 4:1. That's what you are trying to say. Yeah, what is the value of I here? Value of I is 60 kgs because you started with 60 kgs of fresh grapes. All right, 60 kgs of fresh grapes. I is nothing but 60. Substitute I and F are in this particular ratio. I is nothing but 60. Therefore, 60 divided by F is nothing but 4 divided by 1. Therefore, F is equal to 15. What is that you are trying to say? If you start with 60 kg of fresh grapes, you'll end up with dry grapes equivalent of 15 kgs. 15 kgs, nothing but the ratio, guys. Ratio is in the ratio 4:1. 4 corresponds to 60. All right, therefore 1 corresponds to what? Whichever way you calculate. All right, whichever way you calculate. Right, yeah. So therefore that becomes 15 kgs. Okay, the point of this particular question is what? Hey, there is some constant part, unchanging part. Focus on the unchanging part and finish the deal. Okay, let's take one more question. Let's take one more question. Convert from black to gray to white. Let's take one more question. Things will get, of course, better. Take a look at this. Take a look at this. Take just 30 seconds. Read it. Take 30 seconds. Let's read it. Just read this. Yeah, I'm sure. All right, for some of you already answer would have been ticked in your mind. Right now, you have already got the answer in your mind. Let's take a look at this. Watermelon, fresh watermelon, fresh watermelon contains 99% water. Very similar to the grapes. It's a watermelon this time. It's a watermelon this time. So what is that happening in the watermelon? Watermelon has two portions. Two portions. One is the water portion. All right, one is the water portion. The other one is a non-water portion. I'm calling it as pulp. I'm calling it. Hey, you want to use some other name? Don't bother. Feel free to call it whatever you want to call it. You call it, right? The pulp. Now pulp is nothing but non-water portion. Basically, I'm talking. So basically, there is a water portion and there must be a non-water portion after evaporation. Water is getting evaporated. All right, watermelon. What is happening? The dry watermelon contains 98% water, which means you probably kept this watermelon in front of the shop for a few days, all right, in that hot sun. Therefore, all right, now despite the thick skin the watermelon has, some portion of water might have got evaporated. Earlier, it had 99% water. Initially, the water content is 99%. If 99% is water, then what is the pulp? Simple, 1% is the pulp. Remaining 1% is the pulp. The pulp was 1%. 1% of what? Initial quantity. 99% of what? Initial quantity. Even if I don't write, you should understand, because I cannot let loose 1% hanging in the air. 1% of something is there. I need to always attach. Otherwise, all right, the percentage has no meaning. That number has no meaning there, right? Yeah. So all right, that's initial. Final. All right, let's come to the final. Hey, what is final? The final quantity has 98% water. If the water is 98%, all right, then what is the pulp here? Remaining 2%. Remaining 2% is the pulp. All right, 2% of the final is the pulp. Hey, what is constant here? Of course, the pulp is constant. Pulp does not change. All right, even after your evaporation process, the pulp will not change here. Therefore, what is this? These two are equal. What you are trying to claim? 1% of your initial quantity is nothing but 2% of your final quantity. All right, 2% of your final quantity, nothing but initial by final is in the ratio 2 divided by 1. All right, put all the variables on one side, maybe constants on the other side. Of course, the percentage is there, right? Now 2 divided by 1, that is the number that you get. Now what is that author is saying? How many kg of fresh watermelon you should start? Fresh is nothing but initial. F does not stand for fresh. F stands for finished. All right, final product. Final, this stands for final. This is the initial. That's a fresh. Initial is nothing but the fresh. How much fresh I need to start? All right, if I want to obtain 1.5 kgs of the final product, therefore initial divided by 1.5 is equal to 2 divided by 1. Therefore, what is the value of I? Value of I is nothing but 3 kgs. All right, value of I is nothing but 3 kgs. What you are trying to say? You are trying to say that, hey, start with 3 kgs. To start with 3 kgs. After evaporation, when the water become 98%, it is you start with 99%. When the water become 98%, you'll be just left with 1.5 kg. All right, you would be just left with 1.5 kg. Beautiful question. All right, beautiful question. Beautiful question. One more on the similar lines. One more on the similar lines. One more on the similar lines. Read it. 30 seconds. Take it. 30 seconds. Read it. Wonderful constant. Wonderful concept here. Right? Very similar. Pretty similar. Let very similar. 50%. 15%. Let me write it directly, friends. If 50% is water, so what is the $50? What is the remaining 50% is pulp. 50% of what? Initial quantity. All right, initial quantity, that is from the nectar that you are taking from the nectar. Initial quantity. 15% is water. If the 15, I'm writing it directly now. I'm writing it directly because like we already did two. That's what you will be doing in the exam. In the exam, after reading this question, this is what precisely you will be writing. 50% of the initial product, because 50% is water. Therefore, the remaining 50%, 15% is water. Therefore, remaining 85%. Remaining 85% of the finished product. That's what you will get. These two will be the pure honey form, or pure honey form, non-liquid. It will not have any non-liquid. Call it whatever the non-liquid proportion you are calling it, non-liquid proportion. Therefore, initial by final. Therefore, initial by final is in the proportion of 85 divided by 50. All right, 85 divided by 50. All right, that's what we are trying to say. 85 divided by 50. Nothing but, all right, if you want to put them in the simplified form, already, or let me put the other way around here, or other way around here. Let me just double these numbers. Conveniently double these numbers. This is 100 and this becomes 170. You will get a reason why I am making it as 100. Now look at this. How much? All right, now his question is how much of flower nectar must be processed? That's the initial quantity. How much of initial quantity to yield 1 kg of honey? 1 kg of honey, which means final product has to be 1 kg. As of now, it is 100. Convert this 100 to 1 in your mind. Just 100, make it as 1, which means what? You shifted the decimal place here. Shift the decimal place here. It will become what? 1.7. You just have to start with the initial quantity of 1.7. See, in the exam, it would have taken just 30 seconds to solve this. Probably 30 seconds to read and process this information. Another 30 seconds seconds to solve this. If I'm exaggerating, maybe 1.5 minutes to solve this. It doesn't take much more than 1.5 minutes to solve this once you get control over these problems. That's a point I'm trying to make, because this can be the piece of writing you have done. To do this piece of writing, it doesn't take more than 30 seconds, my friends. It should not take more than 30 seconds to do this, right? Yeah. So that's the exam approach. Of course, already I gave the complete illustration of this in the previous two questions. Already, if you are stumped, already if you are kind of stumped, hey, what is this I'm trying to do? Just rewind, go back to the previous two questions, solve it, then come back and look already what is the piece of writing that I've done here, because I have to show you somewhere that how do you write it in the exam, because you never write as much as I'm writing here. Remember that I have to write little more than required to illustrate what I'm saying. But somewhere I have to show you that, hey, how much is the piece of writing that you do in the exam. That's also very important, because you should not confuse that, hey, I have to write so much for this. Of course not, right? Of course not. All right, good. Already you understood. Answer is nothing but 1.7. How much flower nectar I should start with? You should start with 1.7 kgs. Start with 1.7 kgs. You will end up with 1 kg. You will end up with 1 kg. That is precisely the answer, right? That is the answer out here. Pretty similar question, which you will be doing it. All right, which you will be doing it. Let's do one beautiful question. All right, beautiful exam question. Let's stop with this beautiful question. All right, let's stop with this beautiful question. Beautiful exam question here. Beautiful exam question. Let's stop with this. Let's stop with this. I want all of you to give a serious try. 30 seconds. I want to give you a serious try on this question and crack this. I love this question. Very beautiful question. Of course, there are many. This is one of them. Yeah, I'm sure some of you would have solved it. Yeah, I'm sure. All right, now, so let's take a look at this, because this is a similar kind of bargain. The very reason that we love is what? All right, now, so we say that, look, all right, now the what is mentioned on that particular article is 2568. Then the shopkeeper will tell you, ma'am, on this you have to pay tax also. Right, we have to pay tax also, 9% plus 9%, 18% tax. All right, now here it is 7%. That's fine. All right, but what you will say, you will kind of bargain. That's why I said that is my beautiful question. Right now, this is my favorite one of the beautiful question I appreciate. We'll say that, hey, including tax, please do this much. That's what he will tell. Yeah, that fellow will say that, look, all right, now this is what the price tag. On this you have to pay the tax. All right, now you are not paying it to me. That goes to the government. All right, now that goes to the government. All right, exercise. So therefore, all right, now you are paying the tax there. But what you will say that, hey, no, I don't know what you do on this. Including tax, give me at this rate. That's what he will say. That's what precisely author said. All right, that's what he's saying, that including the tax, give me at this rate. All right, including the tax, if I have to give it at that rate, which means the price as this particular product has to change, because on my invoice, that's how I will look at this. All right, there will be a base price. All right, there will be a base price. Then there is a tax that I'm going to add, that I will arrive at the final price. So as of now, how it is looking here, as of now, the base price is looking at 2568. On this, you are saying that you pay me a tax of 7% of what? 2568. So when I add both of them, all right, naturally it will become 1.07% of 2568. 2568, because this is one full 100%, and then you are paying 7% tax on this. Therefore, technically it will become what? All it now 107%. All it 107% of this, or 1.07 times of this. That is what. But you are saying that I am not willing to pay this. On the other hand, you are saying that, hey, you please change this to X. All right, now you are saying that it is 2.68. Fair enough. You change it to X, and then you are saying that, okay, then all right, now so you take 7% tax on this X. And then you tell me that your final bill, the settling bill, is going to be 2568. This is the bargain that you are doing, which we usually do. Therefore, I said that this is one of my, this is one of the nice questions I think about right now, because this is what usually we do, including tax. All right, now making this price. Fair enough. That's what this guy is doing. How do you write, therefore? How do you write multiplier, friends? One single multiplier. You can't get easier question than this. Hey, what is the initial value? X. What is the initial value? X. How much you are increasing this by? All right, now you got to increase means what? The price. All right, tax is nothing but the increase. Because all right, now after that increase, you are getting this bill 2568. Tax is nothing but increase. Hey, how much increase? 7%. 7% is the increase. 7% increase means what? 7 divided by 100. All right, this is plus. Therefore, what is the multiplier? Multiplier is 107 divided by 100. 107 by this of what? Of x. This has become the final number, which is 2568. Such a simple question. This is where we started off with the multiplier, one single multiplier. In fact, today we talked about successive multipliers, one after the other, successive change. Now I am back to the square, back to square one. Nothing but what? One single multiplier. From 2 3 multipliers, I am saying that let's do one multiplier, guys. Beautiful exam question, practical, right? Yeah, therefore x times of 107 divided by this is equal to 2568. All right, 2568. That's what you were trying to say here. This is 107 one time, this is 107 24 times. Therefore, you are saying that x is nothing but 2400. All right, x is nothing but 2400. All right, now, so therefore, what is the price? You should tag it here, 2400. So from, all right, now, so from this particular price, 2568, you need to now change the tag, price tag, to 2400 before you bill. Change it to 2400. Pay the tax of 7%, then the final amount you will be paying is 2568. Therefore 2400. So therefore, all it author is saying that find the reduction needed in the price of the radio. What is the reduction needed? 2568 should become 2400. How much reduction? 168 reduction. Reduce it by 168 before you billing, 168, and then ask a tax on that, which will become 2568. Therefore the answer becomes 168. Now look, this is how the beautiful questions or applications are created based on the similar concepts we learn. Now further few classes, when we do the profit and loss, when we do the discount, or when we do the chapters built on SICI, you realize that hey, all these are the beautiful applications built on this particular concept that we learned. Not only this, even the DI. Right now, these two chapters that we did, all right, percentage 1 and the 2, I'm sure all right now these will serve a larger purpose as we go along. Right, the closure to this, the closure never happens with what I tell, which means whatever I said so far is just an input. Now here all it starts the beginning. So where I end starts your work, and your work is going to be into 2 or into 3 times of what I'm trying to say. Look guys, it's just like a swimming coaching. Right now you can hear the coach's beautiful lecture. He may be talking about the physics, buoyancy. Guys, hold a little bit of water, your body will float on the water, looks beautiful. But once you pushed into the water, you will forget everything. All right, you are pushed into the water, you are done, you don't know what to do. All right, the body is just not floating, as the coach said, outside the swimming pool. That's a reality. Therefore I want you to go back and solve. I want you to go back and solve. Post lecture assignments are very important, right? So if you have the endeavor modules, so go ahead and solve all it now these questions. Already solve exercise 1 and 2 from the QA1 module, and also do the exercise 1 and 2. And if you have the 27 DQC, 27 days to quant confidence, implies that within a month you can prepare for quant really well, right? That is what we technically mean by 27 DQC. If you have that particular book, let's go to the percentage chapter even there, run through the percentage chapter even there, right? So that's the end of my lecture. I hope all that you enjoyed as much as I enjoyed it. Okay, see you very soon with a further lecture. Bye till then, stay blessed.